to, for the telescope essentially to move as the photon is passing slower through that. So you would expect that the apparent angle of the telescope would see the light coming from a slightly different angle compared to with water rather than air. I mean, that's the whole idea of
It would
Airy's
have
theory.
to be,
Well,
unless
it
you want to
wouldn't
throw
be that
out
it
physics.
sees it
Except
coming at a different angle. It would see it
In which
coming at
frame
the
of
same angle.
reference? In
It would
which frame
see
of
it.
reference?
That's
In the frame
irrelevant.
of
This is
reference that the
physical.
telescope is in, or in the frame or in a frame of reference that's outside, that's watching the
That's
telescope move.
That's
You looking at the
irrelevant.
eyepiece of the
That's
telescope.
extremely relevant. The fact that you say
No,
it's
it's not.
irrelevant cracks me up.
It's not relevant at all because
It's
it's
100%. The
physical.
angle will be very different.
Oh,
It's
You
you're
don't
just,
think the angle will be
physical,
different?
dude. Could you stop,
bro.
interrupt, like stop clipping, dude? Please,
It's
just
physical
relax.
motion. So it would be a physical displacement. It's not that the light comes in at a different angle, it comes in at the same angle. It's once it hits the water, by the time it can get to the bottom of the telescope, the angle is greater because the telescope has moved further underneath it.
Testing 1,
Yep.
2.
Stationary telescope predict.
Alan, what up?
What's
Dude,
up,
I
bro?
heard my favorite subject being discussed, and I wanted to chime in and give some clip notes or whatever. Should I hop on the
Yeah,
Yeah,
computer?
please.
what frame of reference are you in? You can't participate unless you're in the right frame of reference. Sorry.
Can I
Well,
just say one sentence real quick? Stationary
absolutely.
telescope predicts no tilt, and that's what's observed. Pretty
Well
simple.
said. Well said. Okay, so there's actually 3 predictions that could possibly be the outcome of Airy's experiment. Now, like they were saying earlier, the angle would have to change. So the classic theory, like if you just do Snell's law and add the velocity component, you're going to get an angle that would be that it would read 36 arc minutes, or I'm sorry, arc seconds for the angle that he measured on the micrometer when you convert it to what it would be for the arc in the sky using his measurement method. Okay, so it would have got the bigger angle if the Earth was in motion with classic physics using ether or no ether, right? Because we live in an etherless paradigm right now. So there's the prediction that the angle increases is still the same, but that's not what's measured. Okay, so that's number 1. Now they came up with applying Fresnel drag to the experiments, but their hypothesis for some reason was that the drag would cancel the light. It would carry it in the opposite direction. It would cancel it out essentially. Okay, so there was a prediction for a null, to not get a change, but that was dependent upon doing a reference frame transformation and analyzing it in another reference frame essentially. And then so you treat the Earth as stationary. You have the incoming light with the velocity component with the horizontal velocity component instead of the Earth. And so when you transform to the sun and you look at it from what the angle would be on the sun moving relative to stationary Earth or vice versa, you get that leftover drag amount ends up in the frame where where it would be the moving frame relative to the geocentric frame that they transformed into. Okay, so they kinematically treat the Earth as stationary, have the light get the horizontal velocity component so that it comes in with no tilt, as my man Locksmith said. Now, the problem here is that in the actual moving frame relative to the stationary frame, they have the telescope angle. It comes out to be 15 minutes or 15 seconds of celestial arc when you convert it from what he read on the micrometer. Okay, so if that were the case, if an actual dynamic moving frame due to Fresnel drag predicts this, then relativity theory would actually predict a smaller angle, because that's the actual angle that comes out of their transformation relative to the moving frame. Now they'll deny that that's a valid analysis and that treating it stationary is the good way to do it, and everything's just fine. But that's not the case, because there's another component called Fresnel transverse drag. Fresnel transverse drag is the exact term that the relativistic transformation drops off at for their transformation to the moving frame. So all they did was basically move what they actually predict into another frame and then discard it. Now, if you add the what relativity predicts for the moving frame to the geocentric frame angle-wise, you get the 36 arc second celestial arc that would have been measured with the classic physics. And that's no coincidence, because whatever the refractive index is that carries the drag gets moved to the moving frame relative to the stationary frame, and they just forget about it, and they just act like that's sufficient enough. But in 1972, R.V. Jones really measured transverse drag down to a billionth of a meter, and showed that that the angle would actually be the smaller one that they predict. It would be the 15 seconds of celestial arc. If it were a real relationship and the Earth were actually in motion, and none of those were actually measured, right? The measurement was that the angle didn't change, and so the only theory that actually dynamically predicts that is one where the Earth is at rest, independent of any reference frame transformation stuff. Because here's the thing with this experiment: the water forces you to pick a preferred frame to analyze the experiment in, and the only one that satisfies it is the geocentric one. I rest my case, Your Honor. There's the TLDR on Aries. Thank you for listening.
Why
so
why
for
wouldn't we use
155 years, everyone got it wrong for 155 years now, and you suddenly
So you
have a
basically just
great-
gave up. So anybody else?
So 155 years.
why not
I think his
use
question
the-
was. I think his question was, why isn't it kosher to use the geocentric frame and just call it Dunsies? Is that the question?
No, I have a question. Why don't we use the moving ether as the preferred frame?
Use the moving ether as the preferred frame.
Mhm.
So even if you used moving ether as the preferred frame, there's still going to be a V over C relationship that has to be satisfied. Moving ether isn't going to change anything like that. Like so.
Well, the ether won't be
like
moving. You'll be in a frame. You'll be in a stationary frame in the ether, watching effectively what appears to be a moving apparatus. Correct?
That would be anywhere that you apply a stationary frame, absolute space, so on and so forth. The same actually applies. Hold on 1 second. Yeah, hold on 1 second. The same actually applies for just the prediction for aberration in general, because it's a V over C relationship, first order, so it's relative to the light medium already anyway. So whether the light medium's moving or not, the conceptualization of the base for the motion to be relative to it is a V over C relationship. So what you're proposing would change absolutely nothing. That's why I said the water in the telescope makes you have to predict, or makes you have to pick a preferred frame, because there's only one measurement, right? Like you can say that the angle would hypothetically be this or that, but every observer has to agree which micrometer chord it hit. So it doesn't really matter. It's going to be the same every time.
Yeah, but the angle will be different, right? You keep talking about angles, and now we're talking about the micrometer chord, but the angle, like if you have
the micrometer chord is the angle.
I'm still going. If you take if you use your frame as the moving this 30 kilometers per second moving ether, which is, I don't get that, because I feel like we see other kind of visual.
We don't even have to invoke ether here, guy.
Well, we need to have aberration, we need 30 kilometers per second of something moving, right?
That could just be an artifact of the sidereal rotation every day, and also the 30 kilometers comes out of ratioing it against the sine of the aberration angle itself and the speed of light to basically cook in what the what was it 154 or what is it, 159 million kilometers or whatever for the astronomical unit. So the speed and stuff associated with it is sectioned out to be a specific ratio of what's to be expected, and then they put that. Then they fixed aberration to everything, like in the ephemeris and whatnot, and applied it to Jupiter's moons for the perturbation series when they were trying to figure out how to explain that and stuff. So it's baked into the model. So the 30 kilometer velocity could be nothing, but the angle that
how could it be sidereal rotation? Explain that.
1 second, because it's just drag. It has to rotate once per day. It just creates a drag effect. Now, in terms of the 30 kilometer velocity ratio could just be nothing, but the 40 arc second swing plus or minus every 6 months relative to the sun's longitude does appear to be, something that's, they say that's what they measured or whatever. So we'll take their word for it.
You're talking about stellar aberration, right, Alan, when you say that?
Yeah, but again, the light medium moving or not moving has nothing to do with it, right? Like, let's just suppose there's no ether, okay? So if there's no ether, right? Because that's what the current paradigm is.
My whole point is,
hold on one second. No, I got you because I'm about to explain your whole point. I'm about to explain it, dog. So just listen. So if there's ether, right, there's going to be a greater angle. So the motion's relative to the ether frame. So any distance traversed through absolute space as the light's propagating down through the telescope is going to cause there to be an angle change. Okay. So that's if there's absolute space, right? Or an ether, or however you want to conceptualize it. Now, the current relativistic paradigm is that there's no such thing as absolute space and all motion is relative. If that hypothesis is true, then in the moving frame, they predict that's where they put the artifact of their drag formula. That's where they predict the smaller angle. And that also happens to be the same exact angle that Fresnel drag uh, uh, predicts for transverse motion. So there's no way around, say, like ether or no ether, doesn't matter. Current paradigm is that there's no ether, but he still measured an angle that corresponds to the Earth being stationary and the starlight coming in at an angle. Which, if you were to accept that kinematic explanation, you would have to shrink the entire universe down to the Earth-Sun system so that the 30 kilometers a second would make sense.
Would hold true exactly.
Wow, that's really great. That's
Hold
what
on,
Is
can we
that
let
good to go?
Pfinky?
right?
Hey, NASA, let's let Pfinky respond.
Yeah, my whole point was take your experiment and move it, instead of being on the stationary Earth, move it to the thing that's moving the light. The thing that, whatever you're claiming.
Let's float in the air, guys.
Okay, hang on a second. Let him cook.
Let 'em
Okay,
cook.
move yourself. Whatever you think's causing the light to or the aberration to occur. It could be ether, it could be sidereal rotation, whatever other thing you come up with. Move it over there, right? And then do the same thing, and then ask yourself, if you're in that frame and now you're watching light come in through water or through air, should we predict a different angle?
Yes. And that angle wasn't the angle that was measured. There's only one angle that's measured in the Earth frame. So
what I mean is, should we observe a steeper angle? What I mean is, should we observe a different angle of the light coming in through air as opposed to coming through water?
depending on which theory you believe in, it's either going to be a larger angle or a smaller angle. Or it'll
I'm
be
saying,
the
if
same
I
angle.
put myself in whatever, are you saying whether I believe in the ether theory of aberration or the sidereal rotation theory of aberration?
We just went over that, dude.
Pinky, we just went over the relativistic transformation and how they say that the moving frame is just an artifact relative to the stationary frame, and that it's all good, because it still hits the micrometer plate the same. Like, even granting that premise, they still actually in reality predict that smaller angle. It doesn't matter what reference frame you try to analyze it from. There's only one measurement. There's only one theory that predicts an outcome of that particular angle that was measured.
Okay, so your method, like your theory of whatever causes aberration, would have the same. Because earlier Witsit was saying that you'd have to have a different angle. Like, it disproves the motion because you'd have to have a different angle for the light when it comes in through water versus air.
Yes.
Yes, that is the asymmetry. That is the predicament that the light, or that using the water field telescope puts them in.
Can I ask something real quick, Alan?
And that's the main. That's the mainstream position is that.
Pfinky, let me ask you something, just to see if you understand this. Why did they need to do Airy's experiment?
Because another dude had claimed that he did this experiment by putting turpentine in his telescope, and he got an interesting result that Airy didn't think was quite the case, and so he was trying to replicate it.
What he claimed to have got would have been the classic the classic Snell's law V over C relationship, where the angle would increase. So, like I said earlier, if instead of turpentine he did water, he's saying that he would have measured that 36 arc second shift. And then Airy was like, okay, let me test that. And then he found that it was the same.
Yeah. Did I answer your question, Beasticles?
Yeah, you're good. This all basically stems from the fact of Bradley's stellar aberration, and then Clinker fuse, and Arago, and then Airy. And there's like this whole progression towards the Airy's failure, which is why it was so significant.
Funny how you guys have a completely opposite conclusion of what they concluded at the time, though, isn't it?
What did they conclude at the time?
There was no ether.
Not the conclusion.
Yeah, so
Who's
so
to
real quick,
say
I
it's
have Nash's still I have Nash's still turned down. Was
Of course
his retort? What was the conclusion at the time?
yeah,
He
and then
said,
that there is
yeah.
no
Yeah,
ether.
yeah. So well, that's not what they concluded at all. You won't even find the word ether in the paper, and if you read Klinkerfuse's original derivation and everything, he opens up his abstract with how there's a difference between apparent apparent motion and real motion, and if the Earth is really is dynamically in motion, that independent of any ether theories, this is what if you add water or a medium to the incoming light for the moving frame, this is what it should increase as. So he didn't even derive anything with any ether variables, so on and so forth. It's actually all classical Snell's law, and he comes to the correct classical prediction through a different derivation. And so his hypothesis was that independent of any ether, there has to be a real consequence of Earth's motion. And then he was like, "Yo, I measured said consequence." And then Airy was like, "Great, I'll check it out." And then so Airy reports that the aberration in water was unchanged, and that Professor Klinkerfuse's hypothesis was untenable because it would have predicted a shift back and forth, adding up to almost the 36 arc seconds. So that's that's all he reported on classically there. They hadn't had the explanation yet of using Fresnel drag to cancel it out transversely via transformation, because that's what Lorentz introduced. So the Lorentz transformation is actually the same as what Einstein what the modern relativists would propose. It's not a different thing, right? But under an ether premise, where the drag coefficient essentially cancels out under transformation, that's what they propose as a solution, which is just math. It's not an actual explanation. And that's what and to satisfy the geocentric frame kinematically, like I said, they would, the consequence of that would have to be you have to bring the whole universe down to the Earth Sun system.
Let's see. So
Alan,
Airy's
So-
failure,
Go
1871,
ahead.
was an astronomical experiment by Sir George Bill Airy to measure if a telescope filled with water changed the
Hold on,
angle
let me
of
turn that
stellar
dude's
aberration.
volume up so I can actually hear him. Give me 1 second.
Yeah, well, I'll start over again. So because you didn't hear. Airy's failure, 1871, was an astronomical experiment by Sir George Biddle Airy to measure if filling the telescope with water changes the angle of stellar aberration. The experiment failed to detect predicted changes under 19th century luminiferous ether theory, ruling out simple ether drag models and paving the way for relativity.
Yeah, you can read the Google AI synopsis or whatever.
Yeah. No, that's not just Google. That's
but-
everybody says the same thing, but okay.
Or Claude, like
Yeah.
we could ask Claude the same question. Or
or you could
Or
read
you can read
the
the paper.
or you could read the papers and have the actual history and understanding for what happened. Because
Yeah,
what I
or,
just laid out, hold on a second, because what I just laid out, right, is that relativity actually makes a different prediction than a geocentric frame for the moving frame if there's no absolute space. If there's no absolute space for the motion to be relative to, and their theory of transformations were true, then the relativistic formula in the moving frame falls back to the classic Fresnel drag formula. And in 1972, R.V. Jones measured transverse Fresnel drag down to a billionth of a meter. So there has to be a real displacement if the Earth is in motion. Aberration in air cannot be the same angle as aberration in water. It is physically impossible. All three theories predict different things, and only one of them predicts the same as a stationary frame using a kinematic treatment. Which is
God,
what
that's
was
really
Jones's
wild. Did you publish this?
Was
Hold on a
Jones?
second.
I mean,
Hold on a
this
second.
is breaking edge
NASA.
stuff. 150-year-old experiment. Wow. I mean,
Is that
you
all
know
you
better than
have
everybody
to
else.
say,
You must
dude?
be so
NASA.
smart. I'm sorry. I'm sorry. I'm
NASA.
not so smart.
NASA, in 150 years, 155 years, the explanation has remained the same and it's gone unanswered. The relativistic transformation is insufficient to explain it in lieu of the transverse drag being
Well,
measured.
I don't suppose you have somebody who actually is a scientist and has actually done experiments to. I mean, I don't suppose you actually have facts to support this, do you?
Yeah.
Can you actually address what's being said
Yeah.
to you, or are you just gonna just do ad
Yeah,
homs
like-
and
like-
wow,
like the-
wow, I
not only
completely don't
do-
go
hold on a
against
second.
mainstream
Would you like
science?
to be kind
Wow.
enough?
Second.
Would you be
Hold on
kind
a
enough
second.
to? Would you be kind enough to link a couple of those to me?
Yeah, it's in the main chat. So If you click on
I
that,
don't
there's
see anything.
there's a presentation associated with it that's cited that has everything, has all the math. There's a Google spreadsheet that has all the math for all the theories and what they predict. And there's a simulator that shows how the measurements worked through the telescope, what they would what the observer would see, what's
Allen
predicted.
Space Audits.
Yo,
That sounds like a real good source. Yeah.
how are you gonna start trailing off in the middle of me explaining to you the thing that you asked? Like I'm
Well,
not
no, yeah, I
gonna.
mean, I asked for like scientific papers, and you link me to Allen Space Audits.
Okay, guy. As you read
.github.io.
through, I'm just going to mute you for a second because this is ridiculous. As you go through the link that you didn't click, you'll find that every slide is cited. If you go to the GitHub, you'll find there's a sources page. It has all the primary sources except for 2 that were too big to fit on GitHub. And then there's even a screenshots folder that has direct screenshots of what's being cited and where the formulas apply. You can also go to the Google spreadsheet that has a sources tab on it that has all the sources screenshots laid out in order so you can see where all the formulas and all the explanations come from.
So
It is
the
one of the
first
most
guy,
well-cited presentations I've ever done. So
the first
you're
guy is
happy to look
Malcolm
through that while
Bowen.
simultaneously saying, "Oh, I was asked."
So the
It's all
first
there.
guy is
Go read it.
Mal.
Enjoy.
So the first
And
guy is
I
Malcolm.
can't hear you because
Oh,
you're now
you got
muted
me muted.
because I can
Okay, well
like
then
I can tell right
I'll
now as I'm
fucking talk
telling
over
you
you for a
this and
while.
you're talking over me.
Then I'll
That's
fucking talk
something a
over you for a while.
fucking retard
Yeah,
would do.
I'll
Yeah, he's
fucking talk over
definitely
you for a while. If
talking
you're gonna
over you.
talk over
That's all
me,
he
then
does.
I mean,
Nasa, cut it
can you
out,
Yeah.
mute?
bro.
No,
You
Yeah.
need to
So
unmute.
wait a minute, hold
you're
on. Why
done,
can
dude.
why can he mute me and then
So to end this
continue to talk?
interaction,
How come he gets
instead
to
of
overtalk me and I
looking
don't
at
get
the
to overtalk him?
material, looking
Why
at
does
the
he get to
math,
mute me
trying to
and
find
not
a way to
talk?
refute it,
Someone
going through the
tell me
history
why.
and like learning it, you're just gonna fucking talk over me. That's insane, dude. So now you're out of the conversation. So your contribution was nothing. Thanks.
Yeah,
Yeah.
that's all he does, Alan. I mean, don't worry about it. Don't take it personal.
Yeah, it's
Because I
all
mean,
good.
you asked for citations, and then he told you that the link is like abundantly flooded with that. So you
Dude,
should just say thanks, man.
not only abundantly flooded, but readily available to download directly from the GitHub. So you don't even have to do any Anna's archiving. You don't have to go any sci-hubbing. It's literally all there for the user to read.
I'm guessing you've done this already. If I point Claude at that, say go read all this, read all the sources. Tell me what you think. What do you
You
suspect Claude will say?
outsourcing your brain to like AI. Can you just read
Yeah,
the
I mean,
paper?
was this not built with
Claude,
it? Was this not
so
built
one
with
second.
Claude?
All
Hold on,
LLMs.
hold on. Nope. Okay, you guys did this to Franco. Like Franco spent 10 hours writing up a response to you guys, and then you guys chucked it into Claude and had Claude spit out a response to it. And now you have the gall to come in here and say
Total trauma.
and try to gaslight me into thinking that that's bad. That's bad. Bad
So
faith.
So whether or not we use AI to parse things, right? The argument and the math stands on its own. That's why it's all included, and you can analyze it and you could read through the sources. You could look at the formulas used and see how they apply. Okay. What Franco's end, even granting Franco's premise, because here's the thing, right? We've read all this and been through it. We don't need Claude to do it. Right. It's not like this argument came from Claude. If you go and give an argument to an LLM, it can say different things depending on different factors. It's literally a probability machine. We don't get our source of truth from what an LLM says, right? What we say is logically backed by the citations and the math. So if you want to attack any of that, you're welcome to do that. It's all available. Now, even granting
Yeah, but you didn't
Franco's
answer my
premise,
question.
hold on one second,
You didn't
because
answer my question. You
I-
didn't answer my question.
dude, your question is
I
irrelevant.
asked you a
Hold on one
question, you
second.
don't answer, and then you monologue.
Dude, you're just gonna fucking do the same thing that dude did. I'm telling you that your question is irrelevant because you can go through all the citations, you can go through the math and come to your own conclusion. Okay? My conclusion is supported by the math. What Franco tried to argue, even granting his premise that the angle is just an artifact of the transformation, there's still a real transverse drag component that was measured in a lab that has to be accounted for. That's being dismissed. And if you grant his premise on the kinematics of the transformation, you have to have an Earth-Sun's entire universe to create everything. And he said, quote, "Oh, I do see the problem with that," and then never said anything else about it and changed the subject. Right? So like trying to appeal to whatever it is you're doing or whatever doesn't fix the fact that if you're going to satisfy it through relativity, you believe in a tiny universe. Otherwise, the angles don't make sense.
Alan, did Aries believe that the Earth moved through
Oh
the
my
solar
god.
system?
Oh my god.
Even
Brother.
if he did, that doesn't matter at all because there's experimental evidence that contradicts what people believe. Right? Everyone
Yeah.
in the Royal Society
No, I'm just
apparently
asking.
believes
I don't want
in
you to go
that.
off on a tangent. I just wanted a yes or no to that question. Did he believe
Oh,
that
hold
the
on,
Earth?
hold on, hold on, hold on, hold on.
And I still
Before
would
we
like
go
an
into a
answer to my
different subject.
question.
Yeah, exactly. All right, Pinky. You brought up Franco as if like it was unfair what we did to Franco. Franco made his own bed, dude. He said that it was a moving stationary frame.
I'm not talking about the argument. I'm talking about the idea that
Oh, you're not talking about the
took
argument.
I'm not. No. Did you not listen to what I said? He took time to write up a response. You guys, like 20 minutes later, had an update posted on your site that obviously had been just run through with Claude and spit out. So that's fine. I actually don't have a problem with
His
that. What I have a
his
problem
res-
with is
his responses to us. Oh, I see.
what I have a problem with is then if
Why are
I
you
say
interrupting, dude?
No, I
if I
was interrupting him. It's fine.
yeah,
Okay.
it's fine. It's all good. If I suggested, hey, what if we had Claude look at your thing and evaluate it? And you guys were like, well, why are you outsourcing all your thinking to Claude? And it's
No,
just, it's
that
a
was
simple
me. That
question.
was
My
me
question
that
is
said
just,
it.
I know, and that's why I responded to you with it. My whole
Why
point
don't
was
you
just,
find out?
what was the question? Have you guys had Claude look
Okay,
at it? Say, is there a problem here somewhere in our logic? That, and I'm not saying to like quote the
bigger
mainstream.
question,
I'm saying
Pinky.
just look at it
Bigger
on the
question, Pinky. Is anything that the reply that Claude generated to Franco, was there anything that's inaccurate with it or inconsistent with what we put forward? Because all we did was run what he was saying through it as a reply because he was just reiterating his same position. If you look at the arguments and refutation section and read through it all, you'll see that when he gets into his Discord replies, it's literally just restating the same thing. So using it to efficiently reply to it and like reading it and going, okay, that's consistent with what I would have said. That's not the same thing as, oh, I'm turning over my entire thought process to it, right? That's retarded.
I mean, like it's roughly the equivalent of saying, "Well, I'll just have Claude write a mainstream." Like
Yeah, but
you guys are making the
he's
same
read the
arguments.
paper.
Wow.
He's read
Okay.
the paper. You haven't read the paper.
Pinky, I've read
Let's
all
please
the
stop
material. I have
interrupting.
all the math, right? I have
Sorry.
everything on my side. What I use to generate responses to people who say things like, "Oh yeah, I do see the problem. It would have to be a tiny universe," and then conclude nothing from it and proceed like I don't give a shit. So,
Plot is
so the
okay
real
for me,
issue,
but not
aside
for
from whatever
you.
Claude thinks, is relativity makes a mutually exclusive prediction of an angle. Because if their formula doesn't fall back to Fresnel drag formula classic physics, then it's physically meaningless. So if there's no
Plot's okay
dynamic
for me,
consequence
but
of
not
Earth's
for
motion,
you.
then the Earth is at rest. Okay, you can't say aberration in air proves that the Earth is in motion because when we analyze it from where it was measured on Earth, we get this 20 arc second angle, therefore ball move. And then when you
Fine, I
add
agree with
water,
that. I agree with that. But you
one
can't
second.
say
Please don't interrupt me while please
while
just
you're
let me finish.
monologuing. Yes.
I don't care. I don't care. Just deal with it. So then when you add water to it, you're like, oh, well, we're not going to analyze it from where the measurement was taken. We're going to say that we're going to treat the Earth as stationary, and then say that the sky is moving, and that's a sufficient answer. That's insufficient, actually. That's called kinematics, right? And in kinematics, relative motion is always true. But with the water, we have an asymmetry now. We have to pick a frame to do the analysis in. So you can either have a smaller angle, you can have the same angle if you're geocentrist, or you can have a larger angle if you believe in the Earth moving through nothing and just Snell's law. So
Well,
that
I
is
think
the
my
actual
reply is,
issue,
well,
independent
you're
of a
still going. You're still
meta-analysis
going.
between another conversation with somebody else. Go ahead.
Bro, so you're saying that he basically fully and thoroughly explained to you all of the details, then went the extra step of still manning every grasp at straws explanation that they tried to come up with for your side, explicitly explaining the flaws within, and your response is a meta critique of a conversation with another guy whose response was retarded.
No. You told, I mean, it was a side comment I made. Yes. That's not
Okay,
my
so can you
entire
engage with the
response.
substance?
I honestly, I could deal with probably one monologuer. I don't think I can deal with two.
Well, good thing
You,
that was
you
only
could
like what 15
So then
so
seconds.
you
that's
could
when
you could deal with
you
any of
can't
it.
deal
That's
with
why
it.
you went to a side subject that isn't relevant. Like if I'm
I
talking
did
to
it.
someone
I
about a
made a
primary
comment.
subject,
No,
you'll notice
I
how
made
I
it.
never deviate to things that are completely irrelevant or like side meta critiques or you should why did da. Right? I address it directly.
Yeah,
I expect the
shoot down
same.
their
If you're not going to do
questions.
that, just tell me up
Well,
front so I can talk to somebody else.
well, your critique should be with Beasticles. I made the comment, and then he's the one that brought it back up and kept pushing
Nah,
the bear.
my critique is there's no explanation that physically explains why the angle didn't change unless you use kinematics or deny that the angle would either be smaller if there's no absolute space or that it would be larger if there is absolute space if the earth is in motion. That's the actual argument and subject matter at hand. Talking about anything other than that is suboptimal here. Well,
Let's see about
It's
this.
called
If Alan's
obfuscation.
assessment is accurate, do you concede that the only viable conclusion is the Earth is not moving?
I haven't read through his whole deck yet.
He just said it.
Dude, his
Alan,
deck is
have
like
any of the
48
people
slides long.
Okay, but he just said it. He just explained all
He
of
just
it.
explained it to you verbally.
Like I'm saying, if it's a hypothetical preface, right? Like, do you concede that if his assessment is accurate, the only viable conclusion that actually predicts the empirical measurement is that the Earth isn't moving?
any
Honestly,
of
I
the
have to look through
people
the. I have to
this
look
is
through
a
the thing.
question this is a
Sure,
question for
sure.
Why
Alan.
did you
Do you
jump in
agree? Do you
right then
agree
to
that
make
if
sure he
with the? Do
didn't
you agree?
answer my
Yes, I agree.
question?
I agree. I agree. 100%.
Thank
Do you
you.
agree that if I'm right, then the opposite is true?
I haven't heard you articulate anything
Yeah,
that
what's
would that
your
Do you?
that would
Yeah,
Doesn't
but you
matter.
would need measurement
Doesn't
to
matter.
support your position, though. That's the thing. You're not just arbitrarily right. You would have to have something to substantiate it.
Yes. If I had the measurement to substantiate it, then you would
Yes,
agree that I would
yes.
be right. Okay.
Yes,
All
Yep.
right.
If you
bro.
could go
no
back in
shit?
They,
time and change the
Fantastic.
numerical
We're all in
measurements of
agreement.
Airy's failure, you would be right. Yes.
yo, I'll say this right now. If they had measured the smaller angle, right, that would have been really good. That would have been like what's the word I'm looking for? That would have been profound proof that there's no
Incontrovertible,
that
or
there that would be profound proof that there's no absolute space because the resultant angle from that would only come from the relativistic explanation where it's for Fresnel drag in a relative frame. So
Have any of the people that have more and more accurately measured transverse Fresnel drag come to the conclusion that the Earth is stationary in their writings after taking those precise measurements?
You could look at the one that he cited Jones and just say, is that paper was his conclusion that
yeah,
siding
so
with Allen
Jones
in any
actually
way?
talks about in the sources you can read that Jones actually talks about how it's applicable to Airy's failure, but he doesn't press anything on it.
Why do you think they called it a failure?
He doesn't press any further than that.
What about the people at the Weizmann Institute in 2020 who measured even more accurately than Jones?
Real question here is why is the angle, the geocentric angle, right? If the Earth is actually in motion, right? If all motion's relative, then they should measure the classic Fresnel drag formula transversely, and they didn't. So there's a huge implication there, irrespective of what anyone believes for, what they thought when they wrote something, right?
sorry for interrupting, guys. My bad. I can hear you guys now.
So the researchers who are subject matter experts apparently weren't able to use their research to conclude that the Earth was stationary.
Not an argument. I can
But
use their
Jones's
same research to
experiment,
mathematically and philosophically show that it should have been different. That should have been their conclusion. So appealing to that doesn't matter, right? And also, like, not that it matters, but there are other PhD people that say the same thing. It's just not widely viewed or talked about, but it's irrelevant. what they believe. You don't appeal to somebody for what they believe. You appeal to the reason for why they believe it. So when we analyze the experimental evidence that they put forward and put it all together, like when we tie several different concepts together, we can form our own conclusion, independent of theirs, supported by the same data that shows a contradiction in what they believe.
Right. So you have a better understanding of the physics of our reality than R.V.
Oh,
Jones
so
or
you
whoever
guys are
that's involved with
literally
this.
terrified of this argument, huh?
I just find
really,
it interesting that Alan thinks he knows better. I mean, he thinks that
You don't even
these
know what
guys
you're talking about, dude. You're
who
just ad
actually,
homing.
who actually took the time to go and do these precise
I know
measurements
one thing, you don't know
somehow
shit. I
The
know
somehow
that.
the versus the
that's a
interpretation
different. I don't
thereof are
know. I
two
mean,
different things.
Can you even still man what Alan said to you? Like even like rudimentarily?
No. I'll put
yeah,
$100
he
on it.
believes that due to the effect of the transverse Fresnel drag, that it's an inescapable conclusion that if the Earth was moving, that Airy should have observed the change in the angle,
Why? Why?
because he doesn't feel that there's any possible explanation that could explain how the Fresnel drag could not have shifted the light inside the telescope.
Not that there's not any possible explanation, that the given possible explanations don't align with what's measured in the lab and versus what those theories predict.
Well, how do
Specific.
you convert Jones's? So this Jones one was a detector on the wall with a spinning disc. So the detector wasn't attached to the thing in motion, right?
Mhm. Yes.
So like how and Aries the detector was attached. So how do you account for that difference?
Well, if you look at the formula, it's just velocity and length of the thickness of the medium. So it doesn't tell you like which one has to be moving or whatever. Like it would be like the same situation with the Sagnac effect. So as long as there's motion, if the Earth is in motion, right? If that medium has a velocity component to it, there's going to be an angle change. That's what the experiment says.
Yeah, but it makes a big difference if it's an angle change relative to a detector on a wall that's not moving with your apparatus versus a detector that's attached to your apparatus, right?
Well, in 1942, there was Dufour and Prunet who had a interferometer set up where the detector and the emitter were fixed to the lab wall using 45-degree right-angled mirrors. They split the light beam path between a stationary circuit and a rotating circuit, and then it reflected back up to the stationary, then back to the wall, and they measured the same deflection angle. Or I'm sorry, they measured the same fringe increase as the regular Sagnac effect. So, irrespective of whether it's moving or not, absolute space is a consequence of this measurement because that's how the formula produces its prediction for the distance changed clockwise or counterclockwise. So in any case, it doesn't matter if the Earth is moving or if the experiment was with the medium moving. They both should predict the velocity component. And so to answer your question even more profoundly, the actual longitudinal Fresnel drag, which was done using sunlight in the interferometer with the water moving, should have actually produced a velocity or a fringe shift of c plus or minus 30 kilometers a second plus the velocity of the water. It should have been a ratio of that rather than just the water's velocity itself. Because so no matter how you try to analyze it, there still would have to be either a fringe shift for the for the longitudinal or the angle change for the transverse. It's going to produce the same thing. They actually there was a Michelson and Foucault in the 1800s between like 1860-ish to 1870, 1880-ish. Michelson and Foucault had done experiments where they were using I guess the detector was stationary in that one, but they had light reflecting off of a rotating mirror, and then it would go through a tube, and then they could fill the tube with water or leave it empty, and they could measure how the deflection angle changes based off of the motion. So in any case, if there's real motion then the detector is going to produce the same thing. The equation doesn't really say which one's moving. It just says that there's motion relative to absolute space. Here's going to be the difference.
In other words, air and water should have different effects on the angle. Period.
Yeah, because if they were going to say like
different
ahead, sorry.
frame,
What'd you say, Pfinky?
not in every frame.
No.
all the observers have to agree on the measurement. Okay, so when an Airy's failure, for example, if it hits the micrometer wire number 13, every observer in every reference frame has to agree on that. Okay.
Correct.
Now, in the Earth frame, right where the measurement was taken, that 13 wire corresponds to a distance on the micrometer. When you convert that to what the celestial arc is, it comes out to be 20 arc seconds. And that's now, keep in mind, that's after you do the. Okay.
Correct.
Now, in the Earth frame, right where the measurement was taken, that 13 wire corresponds to a distance on the micrometer. When you convert that to what the celestial arc is, it comes out to be 20 arc seconds. And that's now, keep in mind, that's after you do the conversion from air to water or whatever, because he had a conversion for his scale or whatever. So I like looking at it like that because it's easier to keep track of the figures. So in any case, he measured, no change that would correspond to Earth's velocity with respect to absolute space. And then relativity came along, what's his name? Lorentz came along and said, well, if we just do this transformation here, we end up with the Fresnel drag term in this moving frame where we have the geocentric frame predicting the null result. Because the whole thing was that they had to keep predicting null results because the only first order velocity measurement of Earth, because that ratio does give the 30 kilometers a second. So they took that as proof that their cosmology was true and what they were doing with Kepler's laws and Newton was correct. And then in 1812, Arago tried to measure the effects of Earth's motion using a telescope with a crystal prism covering the midpoint of it. So when the starlight intersects with the crystal prism, it was supposed to change frequency and displacement. And neither of those things happened. So the very generous conclusion to that experiment was that the refractive index of a moving prism is the same as a stationary prism. And then there was the Fresnel drag experiment, there was the Hoke experiment, there was clinker fuse, all these people trying to make first order measurements of Earth through space. They couldn't get it. As the years went by, the explanations were, maybe there's ether trapped inside the apparatus and it's carrying it in the opposite direction, stuff like that, just like, nothing that you could physically like pen down as a mechanism, just kind of ad hoc. And so that's what they were putting forward. And so there was two big experiments, right, that led to the conclusion of abandoning first order measurements of proof of absolute motion in regards to a cosmological ether that the Earth moves through. And that was before Michelson-Morley. There was a gentleman named Hoke. He took a Fresnel interferometer. He took half of it was filled with water and the other half was filled with air. So when the light beam recombined, due to the velocity potential of Earth having that 30 kilometers a second, providing it to the water, there should have been a larger fringe displacement, and he didn't measure any. And so from that, they took that as experimental confirmation that the idea that the immobile ether that the Earth was moving through was somehow trapped inside the apparatus, carrying it in the opposite direction. So when they measured, measured no change, they took that as, oh, this means that we're confirming our. They took a measurement of no motion as confirmation that they're moving somehow. So, and then Michelson-Morley came along with their interferometer, which was designed to produce a second order drag effect through the there and back light beam as it traverses the plane of the interferometer. And that was supposed to give them their opportunity to get a second order measurement, which they, did not. And then that's where it was concluded that oh, if we transform and analyze it from another frame, we don't predict anything in this frame. And then, Einstein took it a step further, and instead of having the Lorentz transformation apply to the waves, because it would previously, when Voigt and Lorentz did it, they were contracting and dilating the frequency and wavelength of a wave, not the apparatuses themselves. They had hypothesized that because everything is made up of electrons and stuff, that if those wavelengths and whatnot were compressing, that maybe there could be a material, link contraction, time dilation thing. But they weren't positing it as applying it to the coordinate system itself. Now, Einstein took the same formula, same framework, and just said, if we just apply this to the coordinates rather than the wave, the speed of light's constant and the apparatus changes length. And everyone was like, all right, fair enough. And that's basically what they went with. And that's the full rendition of how they came to the conclusion that Earth was moving, even though they could never measure it except for one time in air, and then every measurement involving a medium where you would have to pick a preferred frame to analyze it. They came up with ways to say that those are nulls, so that when they interpreted their nulls as proof that they're moving, like that's a whole different philosophical situation going on there.
Oh
To
yeah,
be
I'm
fair,
Would
correct.
you say that your
Not correct.
position? So, Alan, would you say then your position is that due to Airy's failure and the results of Michelson-Morley, that's proof the Earth is not in motion? Is that your position?
Yeah, specifically with the Airy's experiment.
So your position is because Airy's failure did not show the change in the aberration with the water field, therefore the Earth is flat.
Nope, it's not what. No, it would be a completely different argument. We could assume
I'm sorry,
globe
I
and
didn't mean to say
everything.
Earth. I'm sorry. That was a Freudian slip. I meant to say the Earth is stationary. I didn't mean to say flat. I'm sorry.
Yikes.
Sorry, that was a really
That's
bad
a
Freudian slip.
stationary telescope prediction.
My brain lapsed for a second. I meant to say, therefore, the Earth is stationary.
Yeah, be careful with him, Alan. He says he has a 79 IQ.
Nope, I have a 70 IQ.
Oh. He doesn't even know what he has because he has such a low IQ, according to him.
But Alan, is that your position?
I'm sure it's more accurately like 105.
That is what I just laid out. There are three mutually
Okay.
exclusive
So
outcomes,
why
and only one. So as I'm answering your question, you're like already loading up another one. Are you not interested in the answer?
no.
Does the answer not
Let me
matter?
respond to you.
Do
Like
you
another
want me to
night.
just not say anything and
The
you can
last
answer
one
for
was
me?
crazy long.
Yeah, how are you going to
Last one.
ask him a question and then talk immediately over the answer?
We're just
'Cause-
afraid. We're terrified of how long it's going to be. Go ahead.
If you
Yeah.
want to
Oh, he's
bring
just
up
not
to
gonna
the
know
end
your
of
I would
the
be
room,
terrified too if I didn't fucking listen to anything that was just said and I just asked the same question when it's like there's three mutually exclusive outcomes and only one satisfies it without making transformations or being incorrect.
Yeah, I
Talk shit
zoned out halfway through.
explanations.
Jake may have also.
So yeah, it's just Alan just did a textbook affirming the consequent argument, and yet no flat earthers are calling him out on that.
Hey,
Right?
go ahead and lay it
He's
out.
saying that-
Exactly.
laying it out. If the Earth were stationary, we would not expect to see. Or I'm sorry, I should probably lay it out the other way, which is what you're saying. If the Earth was in motion, then we should expect to see an aberration in Airy's failure. We didn't see an aberration in Airy's failure, therefore the Earth is not in motion. That's basically the argument.
Yeah, there's three mutually exclusive outcomes. So we could use a null hypothesis for it. We could analyze what each theory predicts, and only one of the theories makes the correct prediction. So I don't know how you're trying to turn that into circularity, because if relativity made the correct prediction, we'd be arguing for relativity or Earth's moving.
It's textbook affirming the consequent, because what you're saying is that there's no other explanation for why there's Airy's failure other than that the Earth is stationary.
Yeah, in current paradigm, there are no explanations for it. The results should lead to a different measurement if the Earth is in motion. It would either be a smaller angle or a larger angle. These are mutually exclusive claims.
Yeah, anything else would be a appeal to possibility fallacy.
Now what
This is
could be
literally a textbook affirming the consequent fallacy. I don't know how you guys don't see that.
They gave up at this point, Alan. Go ahead. What were you gonna say?
Yeah. So there's three possibilities that could come out of this, right? If Fresnel drag is true, you could, or if relativity is true and that there's no absolute space, it predicts the same angle. If there is absolute space and the transverse formula is true, then the Earth could be moving through an ether, and the motion would be relative to that, and that would also predict the same angle. But the motion that produces that angle in the formulas is like a mutually exclusive thing to produce that. Okay, so in Earth, in the geocentric frame, like where the Earth is actually stationary, the light medium has the horizontal velocity component already, and that's why it's unchanged. Okay, and for the classic theory, if you were to apply what was it like Snell's law and what Clinker fuse was doing, you would get the larger angle. Okay, so I'm not saying that there's no possible explanation. I'm saying that given current paradigm, can you repeat this part back, Jake, because this is the important part that makes it not affirming anything. There's three explanations, well, four technically, I guess, if you include the one for relativity and the Fresnel drag. There's four possible explanations, right? And three of them all are resultant of Earth being the thing that's in motion, and one of them is where the Earth is stationary. And only the one where the Earth is actually stationary is it consistent with aberration in air and also with water. We don't have to do any crazy stuff. We don't have to make any assumptions. In air, the starlight already comes in at an angle. In water, starlight already comes in at an angle. Okay. In relativity theory, they're like, oh, starlight's coming in at an angle because all motion's relative. And then when they add water, they're like, ooh, because all motion's relative, we're going to treat the Earth as stationary because we know it's moving, and we're going to analyze it from the kinematic geocentric frame, and then disregard the actual moving dynamic frame, which has the Fresnel drag term in it, which would actually predict what a moving frame would predict. Or we could just use the Fresnel drag formula itself and reach the same conclusion that there should be an actual consequence. Or we could use the classic. In any case, there has to be a real consequence of Earth's motion, guys.
Yeah, using the measured amount for the Fresnel drag, keeping in mind that the way that they did this experiment was he was looking through an eyepiece and he had centered the star on the eyepiece and then filled the telescope with water with it centered on that star and seeing if the star moved. And given the measurements of the transverse Fresnel drag, how much should that have moved?
It should have produced the.
Can you show me? Can you show me the math on that?
Yes.
How much it should have moved?
Yes, it's in the link that I posted that has the presentation. If you click on the simulator and then you click on the drop down menu, you can enter the Jones Fresnel drag thing and see what it predicts. It predicts 12 arc seconds for an internal angle, but nobody measures the internal. That's just what it would calculate out to. But the micrometer displacement, which is then converted into the celestial arc, would convert to 15 arc seconds. So they predict.
I reposted it for him.
Thank you. So they predict that the angle should be smaller for the celestial arc. So when they add the water, instead of having it increase in angle, right, like the classic theory would predict, they're predicting that it would be a smaller angle.
So have you reached out to any of the people that have done the more?
Let's do it. If you're a first-time marketer on
right, if Jones measured it to a billionth of a meter, then more accurate would just be that it's the same, that it still applies aptly. So I'm not sure where your line of questioning leads, but I would prefer if you just spoke directly instead of trying to do a roundabout way to appeal to authority.
What about this? What about that?
Well, anyway, and also like, let me just address real fast. Like, this is not fallacious at all. Do you actually not know what affirming the consequent is? And if not, why would you have the audacity to bring it up?
I mean, it essentially is affirming the consequence.
No, it's not. He's
So
denying the consequent. He's denying a consequent. How's that affirming it? So you don't even know what a modus
ask
tollens
him.
is. So just don't. Just don't. You're
You
just
don't
out of
think
your
that
league.
you don't think that when he says
If
the Earth,
Earth moves, then
if
starlight
Earth moves,
deviation occurs. If Earth moves, then starlight deviation occurs. No starlight deviation occurs. Therefore, Earth does not move. That is modus tollens. It is perfectly valid. Please just stay in your lane.
right?
Just
Yeah,
let him
no.
have
So
the straws he's trying to grasp at.
No, but I just need him to understand. Well, like if it was true, then that would be a valid point. But it's not. He doesn't.
so Alan knows.
He's denying a consequent. It doesn't matter what Alan knows or doesn't know. His argument is structurally valid. It's called modus tollens. Isn't affirming the consequent. He's denying a consequent. That's literally the opposite of a fallacy. So anyway, it's if P then Q, not Q, therefore not P. That's modus tollens. Affirming the consequent is if P then Q, Q happened, therefore P happened. That's not what he did.
Exactly. From the consequent.
Yeah,
Earth looks flat.
he's saying P happened, which would be that
No, you're not going to bastardize his argument to try to make it fallacious. I just said what his
the
argument is.
aberration didn't happen, right?
Do
Therefore,
you know what modus tollens is? If the Earth moves, then the starlight would have deviated. The starlight did not deviate, therefore the Earth does not move. P is if Earth moves. Q is starlight deviates. Not Q, starlight doesn't deviate, therefore not P. Earth does not move. That is called modus tollens.
Wow,
He's
it sounds fun to
denying the
me.
consequent. He's not affirming one. My God.
Have you guys just tried like reading the papers and like coming up like with your own conclusion? You guys try that? You always keep appealing to subject matter experts, but like wouldn't you feel better knowing that you're being validated by a subject matter expert, either one way or the other, because you actually read the information and basically try to grasp it and understand it, and then you look to the experts and see what they say about the same information. You don't just appeal to them.
And like, why would you care what they think anyway, right? Like, it's like appealing to Newton. Like, do you have to believe everything that Newton believed in to believe in his little gravity equation?
No,
It
but
doesn't even make any
experts are
sense.
experts for a reason. I think it's
Okay,
actually
so Newton believed
dangerous
that
to be
gravity was a
like,
direct act of God and there had to be an ether. So since he's the subject matter expert, you must believe that now.
well, there's better ones since him. There were experts in electronics in the 60s, and there are better ones. We know better now, right? Same
Did
with
you
rockets
ignore
and
what he
everything.
So
just
you
said
believe in
though?
Einstein. Einstein thought Japanese people were equivalent to dogs
Dude.
and wanted to have sex with his minor daughter. You must believe that's okay and agree with him that Japanese
Why?
people are dogs.
what
Because
did
you
I
have
say
to.
that would
He's a
imply
subject matter
that's
expert.
like
Dude,
that's such a
we know
weird.
better now, as if the fundamental nature of it has changed at all.
Like,
No, I mean, like we know more about like we could list any topic, and there's going to be experts today that are that know more than the expert 100 years ago.
dude, how do you outsource your
So,
entirety?
so which expert should I appeal?
No, I'm not-
So which
I didn't-
expert I should appeal to has to do
That's a
with who
straw
has the
man.
most updated.
Hold on, I want to address the straw man that Beasticles just did. That was a straw man.
Dude, can we just address the actual measurements instead of playing reach around?
Why?
Please.
We
That's
got
Witsit just did reach
Franco.
around. Witsit
Hold on
just
one
did
second,
reach
dog.
around on Jake for
We got
like
our
10
primary
minutes.
source expert here, Franco. So maybe we should just let Franco talk instead of playing reach around with each other. How about that?
There we go. See, I trust the experts.
Go ahead.
So good, dude.
Go ahead and
Take your
post
booster,
what
bro.
Franco said.
No, Franco's here right now.
Oh, is he?
Yeah.
Yeah, Franco, if
Oh,
you're
what's
there,
up,
You want to
Franco?
debate Beasticles?
if you're there,
Beasticles
one of the
1v1 1v1
Pinky,
Franco
hey,
versus
Pinky,
Beasticles.
stop for a second, buddy.
Bro, Alan,
Franco, if you're there, dude.
Literally, you're like a
Franco,
girl. Calm down.
you're gonna make me mute you or what? Is that what we're playing? I have to
You're
mute you to finish so I can talk to Franco. I have to mute you. Hold on 1 second. I got you, bro.
Yeah.
I go to the computer. 1 second, Franco. Can't hear you.
Alan's too sensitive.
No, dude, just relax. Just be courteous.
Alan needs to relax. You need to relax.
You know what you're doing. You're intentionally being antagonistic with interruptions.
Nope. It's bad faith to tell other people what they're doing. Alan overtalks and
That's much better.
All right. Now that diversion is settled, Franco, if you're available and would like to continue the Airy's failure discussion or chime in your thoughts on it or whatever, you have the floor, sir.
Hi. Hello, everyone.
What's up, Franco?
Hey.
I could start off the discussion. What did you mean by moving stationary frame?
Sorry. I don't know what you're referring. Who is asking the question? And
I was
what,
part of the Twitter conversation that you had with Alan about Airy's failure, and
yes.
you mentioned a moving stationary frame.
I don't recall, but exactly the phrasing. But in the discussion, there are two frames of reference that are considered. One that for convenience, I called it the sun's frame, and the other one is the Earth's frame where the telescope is, and those are the two frames which are supposed to move one relative to the other. So there's no stationary frame and no moving frame. One is moving relative to the other, and in one of the two, which is the sun's frame, the starlight, the star from
You
that
say
we are
star frame
observing,
to help you out.
that star is supposed to not change its velocity during 1 year, and in the other frame, which is the sun, which is the Earth's frame, in that frame is characterized by the fact that we are observing that the telescope is stationary in that frame, and the water, when you're considering Airy's measurement, the water is stationary on that in that frame. So those are the two, the what is stationary, what is not. Water is stationary relative to the Earth's frame, and in the other frame, which is the sun's, the star is supposedly not changing its velocity appreciably.
I have a clarifying question, Franco.
Yeah.
In the frame where the water is stationary relative to the Earth, you would
Yes,
you would say that the Earth is also stationary in that frame too, right?
of course.
Okay.
By definition, yeah.
Welcome to stationary.
No, it's welcome to
Well,
a frame of reference. Yeah. Okay.
Yeah. So this is where we were kind of picked up last time with the kinematics and dynamics of the situation, where if the Earth is actually moving, there has to be consequences to it because kinematically you could treat it stationary. But if you were to, kinematically you can treat it stationary. But if you were to accept that, you would have to shrink the whole universe down to the Earth-Sun system to satisfy that, which leads to a contradiction in belief in the size of the universe and whatnot.
No, I don't really see that train of thought. I don't follow it. It's just a matter of frames of reference that you're using that you can always do.
Well, you seem to have followed the line of logic pretty good when you agree to it because the only thing that produces the 30 kilometer a second velocity component to produce that angle in current paradigm would be Earth's motion, or around the sun. So to get that same situation for what's produced, if you're going to treat it as the same, then you would have to have everything be the Earth sun size, the distance away, to produce the same aberration. So.
No, again, I think I've had this objection before. I don't really follow it because what you're talking about is the size of what would have to be the size of the Earth's orbit would be the star's orbit, if you consider
Right.
it relative to the
Yes,
to the Earth.
kinematically, that would have to be the case. Yes.
Yeah,
It's part of the
but
argument.
yeah, but the point is that this is not related to the discussion in that's being done now because now, well, the subject of, or the whole point of the whole discussion is, at least the way I view it, is the discussing what the effect would be given what was observed, say, by Bradley and so on, what the effect would be of adding water to the telescope. And that is a one particular and well-defined question with an answer that is given by the current paradigm, and the current paradigm gives an answer. The question that the objection that you're raising now, is and was also raised by Piers and so on, is something that has to do with the consequences of measuring aberration without even filling the telescope with water. That they Bradley or whoever else measures aberrations measures that is consistent with the relative velocity between the star and the Earth's changing by plus or minus 30 kilometers per second during the course of the year, and that then you have to explain that is a completely different question. That's something that has got to do with the explanation of aberration itself, not with the explanation of what happens when you fill the telescope with water. That's
It
a
was in
separate.
relation to that, though.
Yeah, it was
in relation, but what's different? But it didn't. If you use this objection, you don't need to consider Airy. You just start with Bradley and just measure aberration without
Right.
adding at
Air,
all.
right?
Right, but in air, that's not a mutually exclusive to either model, because both would make the same prediction: the starlight coming in at an angle already from the sky moving, or the inverse, where the Earth's moving and the sky is stationary. But what's really important here is that would you agree that relativity theory falls back to the Fresnel drag formula?
The relativity theory, yes, Fresnel's formula is a first order approximation of velocity composition. Yes.
Relative velocities, yes.
But that's not what I was saying. I mean, I don't know if
Hold on a
you
second.
followed my answer to the previous question. The question of how do you explain the fact that if you explain aberration as a measurement of a 30 kilometer per second relative velocity, then you have trouble understanding it as well.
Say we grant that. Hold on, wait.
Some have trouble. Some may have trouble, and saying that would imply that the stars would have to describe an orbit which is the same size as the Earth's. Yes, but that's not due to Airy's result. That's due to the aberration result itself and the way you interpret it. That's nothing to do with filling the
Hold on,
telescope
wait,
with water.
Franco.
So, yeah, hold on for a second. Hang on.
Let me just.
I got Beast. 1 second. So that's just the 30 kilometers and the shrinking the orbit of the stars to the Earth Sun system. is a consequence of the kinematic treatment. Now, putting water in air was to versus air was to differentiate between Earth really being in motion and not being in motion. And the reason I asked about the Fresnel formula is because if relativity theory for a moving frame makes the same prediction for how much should be displaced as the Fresnel drag term, then they would have to predict a smaller angle in the moving frame, because independent of relativity theory, like let's just say the Earth is in motion and there's an ether, the Fresnel drag formula would predict a smaller angle, right? And that like there has to be a consequence of the motion, and analyzing it through kinematics or putting the drag term in a frame that you're disregarding doesn't mean that the term shouldn't produce a mutually exclusive outcome, because it does, and that's what was measured, experimentally.
I'm not following. Sorry.
It's
So it's the same formula, right? It's a first order formula. Okay, it predicts the angle change due to a relative velocity. When you apply it to incoming starlight in a telescope, it predicts that Airy should have measured a smaller angle.
No. Again, I've tried to show many times that no, and this is what I said from the first moment I heard about this, that the only prediction that the only effect of adding water in the telescope would be that in the telescope's frame you would have Snell's law. That's the only effect. And then if you want to change and see what happens in a frame where the water is moving, because that is the frame that was used in order to make the prediction at that time. Because
it's assumed that it's in motion, right? It has to be validated.
You don't in the current framework. You don't need to go to the other frame in order to predict what happens when you add water. That's the point. Why was it used in the past? Because that was predicted to be the frame where ether was stationary, and so you know what happens when air enters water in a frame where ether is stationary. But without ether, if you assume that's my take. If you assume relativity, you don't have an ether frame, and so what you do is just make the computation in the frame where water is stationary. And and there's no need to go back to the frame where water is moving, because that complicates things. But
why does it complicate things?
If you really insist that you want to see things from the frame where water is moving, then you have to add velocity compositions or Fresnel's drag, which is the same to first order, and then you see that the predictions are actually the same. You insist that they're not, but they are.
So they're literally not, because you can do the Fresnel drag formula and show what the internal angle would be and show what the conversion would be. So it doesn't lead to the same thing. It does.
It does.
Franco, just give me a second. Just give me a second. It's a first order term, right? It leads to a first order difference, right?
Yes.
But when you transform to another frame, you're taking the drag component and just putting it in the other frame and analyzing it from kinematics, where the velocity component already comes in from the starlight. Okay. When you add the water, now we have a medium that's moving, right? If you assume that the Earth is in motion, then that drag component leads to a smaller angle. Now, if relativity is true and there's no absolute space and there's no ether and all motion is relative, that smaller angle is the same angle that Fresnel drag predicts if there is an ether and there is a Fresnel drag term for an Earth moving through it. It's a specific consequence difference.
Yes, and
so if they both make this like the same prediction as a dynamic consequence of Earth's motion, then hold on. Then treating it as kinematically stationary is an insufficient explanation to actually explain it.
It doesn't match the measurement, Franco.
Sorry, I had to be away for a second. Sorry, I missed some point. But
Yeah,
if I
take your
may,
time, dude. You're good.
okay. So
Take your time. When you come back, just tell everyone to shut up and you're ready to speak, and everyone will quiet down.
Yep.
All right. If somebody could unmute Pfinky if he's still here, he can participate while we're in the waiting room.
Dude, because I'm a layman when it comes to this stuff, but I understand the concept. Like, you have an angle in air, right, from Bradley, that also assumes Earth in motion around the sun, right? So that's a fixed ratio, essentially, if you keep that velocity component the same.
Yes.
Right? So if you add water in the telescope, doesn't matter relativity, not relativity, ether, no ether, you should have a different angle change, period.
and you
Smaller,
do.
bigger.
The only way
you have.
And the only way it could be the same. Sorry, real quick, to round off his point, the only way that it could be the same is if the starlight already has that component and the Earth is stationary.
Stationary,
Because
exactly.
that's how they have to kinematically treat the experiment to even attempt to have an explanation for it, while simultaneously assuming that the Earth is in motion.
Right, because it doesn't match the ratio of Earth being in motion and having an aberration in air versus aberration in water. That's what I was trying to ask you earlier, Franco. I don't know if you're available, but I was going to ask a clarifying question. Do you think that there should be an angle change in the water versus the air? And you're saying no?
I'm saying no. Let me rephrase it. This I've been saying for 2 years since the first time I was confronted with the question, and the question. I'm sure I'm not the first one, of course, but if someone is confronted with this question, what would happen in this situation when you fill the telescope with water, and then the answer is in the modern view is only one, which is in water you will have an angle change which is determined by Snell's law, which is refraction. That's the only thing, because that and indeed you see that. When I first saw, again, I'm sorry to repeat this, but when I first said this 2 years ago, I was yelled at and I was told that that was not what was measured, and indeed it was measured. Now people have realized that it was measured by reading correctly, reading properly Airy's paper. It was measured, and it was corrected for the Snell's law in the telescope filled
That
with
means there'd be
water.
no aberration.
Yeah.
Sorry?
So real quick, Franco, I 100% agree. And we were kind of talking past each other because I didn't understand fully what you were presenting with the internal angles and Airy's conversion and stuff. So,
Yes.
when I read that, it finally, it made sense in what you were saying, but it doesn't change the argument in that there's, still different outcomes that would have to have been measured. More accurately, talking about the internal and conversion, to the celestial arc and stuff is one thing, but it still requires there's still two different outcomes would be resultant of that velocity.
No, I'm sorry. No. And when you say that it should have measured the different angle in the different frame, it's not true, because for one thing, there are an infinite number of possible frames that you could make the calculation of. And guess what? In each frame, you get a different angle, because angle is not a thing that is invariant between frames. So if you take a frame, I don't know, Mars's frame, or some any other frame
Until you add water.
Franco, it's a fixed ratio that creates the aberration angle. There's only one measurement of it that took place in the lab frame,
which is the only measurement is the one made by the instrument that you're using, and the instrument that you're using is a telescope which is stationary with respect to Earth, and you have to predict what the measurement would be there, what the telescope will measure. And again, you say that if you see the things from a different frame, which is a sun's, in that frame, the angle will be different. Okay, but that's not what you measure. Again, I told you again many times. Try and compute what the telescope would actually measure, which is which wire would be struck in the eyepiece. And if you do that, sorry, but the calculation that you or Claude or whoever did in order to reply to my request is wrong, because you did what you did was to multiply the length of the telescope by the angle, and that's not correct, because that would be the displacement of the sunlight. But then you have to what is measured is the displacement of is the difference between the position of the starlight and the position of the center of the telescope, and that moves as well in the frame where the telescope is moving. So you have to compute that difference. So you don't have to. You only made you only did a part of the calculation, which is the angle multiplied by L, and then you have to subtract from this the velocity of the telescope multiplied by the time it takes the ray to traverse the telescope. So you have to do the calculation complete. If you do that, you will find that the displacement is exactly the same. You can do it. It's very hard to do it in a voice debate. You have to do it on paper, and you do it, and you get the exact same result, which is completely consistent with the fact that one is derived from the other through a transformation between frames. Of course, it's consistent. And if it wasn't, it would mean that the calculations would have been wrong, not the physics, the calculations. They have to be consistent, and they are. And you can even the very fact that the Fresnel drag is that expression, is that mathematically expressed like that, comes from the fact that you actually derive it with velocity compositions starting from the frame where the water is stationary. That's what is done. So of course it has to be consistent, and if you check it, it is.
Can I get in real quick? Okay. So you said that the math was done wrong. And you have to do a conversion from the micrometer to what was displaced. I did that. It's done. You can change in the simulator from how you want to view it as internal angle, external angle, or micrometer displacement converted into the celestial arc. So all of those comport and give the same, or give the correct answer. And on top of that, right, if we just analyzed it with the Fresnel drag formula that Jones used, we get also the same result. I'm just going to say this one more time because we're kind of just going in circles, and then you can close out or whatever. But the treating the Earth as stationary, or treating the telescope as stationary with respect to a stationary Earth, is the kinematic treatment. That is the scenario that produces the sun, Earth, solar system size, or universe size, to have the aberration be the same, which you disagree with, but you recognize the consequence of. Like, relative motion is only true in kinematics. When there's a dynamic asymmetry, you have to pick a preferred frame to analyze it with. The only frame that we have to analyze it with is the frame that we have two different assumptions about, whether it's moving or whether it's stationary. And no matter which theory you use, relativistic theory, classic ether theory, you result in an angle change. The only way to make the angle be the same, that match what was measured in the lab, is by assuming that the Earth is stationary and that the starlight already has a horizontal velocity component. That's the thing is that's being overlooked here is the consistency for aberration in air versus aberration in water. Because in air, it's a first order ratio of V over C. And everyone's content to say that ratio gives 30 kilometers a second. Therefore, Earth move. It was measured on the frame that we were assuming is in motion. And then when we add water, the angle didn't match any prediction that would correspond to the Earth being the cause of the motion where the angle has to be smaller or greater. And so they concluded that, well, if we do a transformation to another frame and already assume that Earth's motion, when Earth moves relative to that frame, we can look at the angle differences that would occur. And you would have to concede that you don't have any mutually exclusive proof that the Earth is in motion around the sun if you have to use a geocentric frame, which already assume which you're using as like a kinematic frame, not like a real dynamically stationary frame, and assuming that the Earth is in motion, and it would have the same consequence, even though it leads to the Fresnel drag equation, which shows that it should have been a different angle. This should have been the smaller one. So you're free to respond to that, and then I'm gonna hop off or whatever because I got some stuff to do.
Okay, so I've not checked what you call the simulation that you published on your page today, but I checked it I think yesterday or 2 days ago, and it was still wrong. It's wrong in many ways.
Send me the specific correction for what you think is wrong then, because I don't know. I'll have to look at it.
Okay,
with exact wording or whatever.
I'll just mention a couple of things. In the simulation, when you have the picture of the starlight actually moving across the wires, it's the orientation is wrong. There's a very, very badly wrong thing, which is you picture a distance of the star to the meridian, and that distance is as the star approaches the meridian, the segment that is pictured in the animation is shortening because the star is approaching the meridian, but the number which measures the distance is increasing, which is completely a complete contradiction. I don't know where that comes from. It's clearly a bug in the information.
Yeah, it's just a simplified version of what the map is producing. But no, you're right. I should correct that. I see what you're saying now. I should definitely fix that animation.
Also, if you read the paper, what was measured was not the distance of what is in that picture. It's not the distance of the starlight of the star to the meridian. It's the distance along the meridian when the star crosses the meridian. Because what Airy measured was the angular distance between the star and the zenith along the meridian on the north-south. So it's 90 degrees with respect to what you're showing, and also the timing was indeed measured by orienting the wires the way it's shown in the picture. But that was determined. That was done at a different stage of the experiment, just to measure the conversion factor between timing, between arc, and between the distance, interwire distance and arc, because you knew when the stars move, when the star move east-west, you know their angular velocity in the sky. So if you measure by how much time it takes to cross two consecutive wires, then you know what arc it will have described in the sky. So you know the conversion to apply from between wire distance and arc, and that is a calibration measurement that is not the measurement of the experiment. It's just an accessory measurement in order to assess and to determine this calibration factor. And so it did that, and then if you read the papers, it did that, and then he rotated the telescope by 90 degrees, or the eyepiece or whatever, by 90 degrees, so that when you actually make the measurements, the wires are perpendicular to the meridian, not parallel to the meridian. And so when the star crosses the meridian, you count how many wires it's the hit wire is from the center of the eyepiece, and that's the measurement. You want to measure the distance, the angular distance along the meridian between the star and by the way, it was not 20 degrees. 20 a second, it was 83, and it was 28, 120 one time, and 83 the other time, and then took the difference between between March and September and divided it by 2, and that's the 20. It's not what he measured actually. But this is one thing. And then in the simulation, when you compare, in another page, when you compare the prediction in the stationary frame, in the Earth's frame of the two angles, where you correctly show the Snell's law, and then you make the same take the same picture of the movement of the starlight, which then goes through another path. The path is different, and the angle in water is different. But then you change it from the famous 15 arc seconds to 11 arc seconds. There's many mistakes. One is that the sign is different. Again, in one frame it's positive, and in the other, and that is fundamental because and I showed you. I can post it again. The actual comparison of the two. In one of the two is towards you. When you move towards the light comes towards you. So it's in mind convention, it's a negative angle, and when you see it from the other frame, it's positive because it's dragged in the same direction as the motion. That's one thing. And the other thing is that if you show that. If you really want to show what the path of light and it is in the frame where the telescope is moving, you cannot show a stationary telescope because in that frame the telescope is moving, and so you would have to show it moving, not just the starlight. Also, the telescope should be moving. Also, the angle in the air should be 0 in that frame, which is something which you never address in your objection, because if you say that in water you should have measured 11 arc second because that's what's seen in the frame, then by the same token it should have measured 0 in air. So the angle is 15 degrees on the Earth, and it's 20 in air. And if you go to the sun's frame, it's 0 in air and it's 11 with a different sign. It's minus 11 in water. And then if you do the animation properly, which is what I tried to do in my slide, where you have moving telescope and you have two paths, one seen from the frame where the telescope is moving, which has the famous 11 arc second, and the other one, which is the negative sign, which is the path seen from the telescope. You can put them in the same picture, but then you have to have a moving telescope. I can post it again if you want.
Yeah, go ahead. I fixed the sign issue. I just kept it simplified for, just like one way of looking at it, analysis. And then in terms of the conversion stuff, I'll take a closer look at it and see what's up. But probably have to get with you and get the specifics on that. But yeah, I'd rather have it more accurately represent what was your how it was measured, rather than like a simplified rendition of it. And some of the stuff was just animational stuff that can be fixed or whatever. But yeah, I'll do that. And then there was a couple other things.
Is it possible for me to upload things here on this, because I'm not really expert on Discord?
Yeah. What you want to do is go to the live stream one text chat and put the information in there. You should be able to upload in there, no problem.
Okay, I'll do that.
But yeah, I'll get the correct angles represented. But to be clear, though, the angle, like using it from transverse drag, like it does produce a different angle. It doesn't produce the same. So it's still going to be different. And you were saying about what was it?
He was saying it's the same. It would be the same.
Shit. Oh yeah. Predicting it in air versus water or whatever. I left it as 30 to just be consistent with what was actually measured or whatever. But I can change it so that it predicts it in air or whatever and shows that it's going to be the same, or it'll be what's measured. but I appreciate your feedback. All right, I'm heading off for the night, lads. You guys have a good evening.
Later.
I was curious in terms of Franco, in terms of what you said that the velocity of the star is constant, and I'm wondering, is that relative to the moving frame of the sun or the stationary frame of Earth?
You said the water was stationary too, or treated as stationary.
So no. So in what I call the sun, can you hear me for one?
Yes.
Sorry. So in what I call the sun's frame, it's not true that the star's velocity is 0, because you don't know that. We're not making an assumption on that. But it's true that we're assuming it not to change during the 1 year, the period when, for instance, in 6 months' time, which is the 2 times where you change where you measure the aberration angle. If it didn't change, the changes is the relative velocity between the sun
You cut out, Franco. But it sounds like you're saying that this velocity of the star is relative. It's relative to the sun's moving frame.
Hello?
Yeah, we hear you now. There you go.
I lost the connection. So
No, lost connection, Dodge.
so can I repeat the answer, or
Yeah, you cut out. We didn't even hear you. You were answering Percentage's question about the sun's frame versus the Earth's frame, and which one's moving and which one's stationary, right? Something like that. Percentage. You want to repeat your question?
not percentage, but I was saying that again. Sorry, I'll
No, that's the
repeat
guy. That's his name
the
who asked you the question.
Oh, sorry.
Yeah, you're good, bro.
I think I got my answer
Sorry.
though. That basically
Okay.
the star's velocity is constant relative to the
Yeah,
sun's
it's constant.
moving frame.
The point is, if the Earth's velocity was constant as well, you wouldn't see anything. You wouldn't measure any aberration. You would just measure a constant angle of the starlight, and that's it. But the point is that this relative velocity between the star and the Earth is measured to vary with a yearly, and not just this star, any stars. It's measured to vary. The constant velocity is measured to vary in a way that's consistent with a 30 kilometer per second motion, almost circular motion of us around the sun, or of the rest of the universe with respect to us, which kinematically is the same, of course.
Mm.
Do you want to follow up percentage or?
I'm just trying to like mentally work it out. It seems something seems off, but I might just be me being ignorant about it. But in terms of like the star's constant movement based off of the sun's, you know, I feel like it wouldn't be constant in the heliocentric model. I don't know. It feels like relative to the Earth, the stationary Earth, with the Earth, you know, if we're just imagining it that the Earth's stationary and the sun's going around the Earth or what have you, like relativistically, like kinematics of it, I would think a third you know, object, a third celestial object, a star, which they say is constantly going outward, you know, it wouldn't be so like smoothly, like so constant to the Earth that's stationary. I don't know.
No, you're right. You're right. That's why I'm saying that we're supposing that star not to be that velocity not to be changing appreciably and measurably during
So
1
they just
year.
make it negligible. Okay.
Yeah. No, I mean, you can measure. There are ways that you can measure the stars, a star's velocity relative to Earth, and especially the ones that along the line of sight. And for instance, that's his Doppler effect. The Doppler, you have the famous redshifts, and that is as a way of measuring a star's velocity relative to us. During using spectroscopy and knowing that seeing that the spectral lines have been shifted, and but there's also other kind of motions that one can measure, like proper motion. There are stars which are actually measured to be moving. The relative position one with respect to the other is seen to change. One of the most famous is Barnard star. You can look it up. You can see the photos of the position of the star in the course of years, and then it's moved. Also, stars close to Sagittarium A star, which is the supposed center of the galaxy, where a massive black hole is supposed to be. You can see stars which are actually orbiting the center in an elliptic orbit, and that's one of the evidences that are pieces of evidence, of the presence of a massive black hole at the center of the galaxy. You actually measure actually see the motion of these stars which move in elliptic orbits around the center of the galaxy.
So if that's the case, then how come we treat it as a negligible thing in terms of stellar aberration, in terms of these observations?
Because it doesn't change appreciably during the course of 1 year. That's the thing. What Bradley and Airy measured was the change in the apparent angle of sigma Draconis or gamma Draconis between March and September of 1871 or 72, whatever. So that changed, that relative velocity changed by something that is consistent with the 60 kilometers per second in a direction that's perpendicular to the line of sight, and you measure that, and then you interpret it as you wish.
Fair enough. Thank you.
problem.
In terms of your animation that you put, doesn't it just seem simpler and cleaner that that the Earth is stationary, the telescope is stationary, and the light is just coming in at an angle?
The animation that I put in is the telescope as seen from the so-called sun's frame, where the one where Alan claims that he should have measured a different angle. And indeed, you would have measured a different angle if you had observed things from that frame, which you didn't, because we did observe it from the Earth. But if you insist that you want to see what happens when seen from that frame, that is what is supposed to happen. I mean, there's a moving telescope, and there's the water coming in, the starlight coming in, and it's partially dragged by the water, and so it makes that particular angle that you can compute, and then it hits the bottom of the telescope at a certain position, which corresponds to the position that you measure when you are in the telescope's frame, and you just see the starlight undergo Snell's law and ordinary refraction.
Yeah, no, I'm referring to the telescope's frame, like that second half of the clip that you put. It just seems cleaner. It just seems simpler,
of course.
Less assumptions.
Yeah, of course. No, not less assumptions, but of course you know what happens there. That was my point, and that is everybody's point in the current framework, because nothing tells you that you cannot just even if you're assuming that the Earth is going around the sun, you can also always choose the frame of reference that is most convenient for your calculations. And the most convenient frame of reference for these calculations is the Earth's frame for a number of reasons. One being that we are on Earth and we're measuring things on Earth. The other being that in that frame, water is stationary. If you want to know what happens when light crosses a microscopic medium such as water, we have a model and we have measurements, and we know what happens when the medium is stationary. When the medium is stationary, when the medium is moving, you have that things are complicated. You can still solve Maxwell's equations and so on, but you have to. It's much more complicated. It's the same thing.
Do you have a preferred frame of reference, Franco? Is your preferred frame of reference that Earth is moving?
It's a convenient frame of reference. In special relativity, and also in Galilean and Newtonian relativity, you don't have a special frame of reference, meaning that all inertial frames are equivalent. This is true both in Galilean Newtonian relativity and in Einsteinian special relativity. So you don't have special frames, except that you have to restrict yourself to the class of inertial frames. These are special, but within the class of inertial frames, there's no preferred frames. But that means, the meaning of that is that given one frame, any inertial frame, then the laws of physics are the same, meaning that given the same initial conditions, you get the same result. And which is a different thing than saying that in a particular problem, given the conditions of that problem, there's a frame that is more convenient. There can be a frame that is more convenient for making calculations. And for instance, if you have a medium such as air or water or whatever, that you know the description better when that medium is stationary, then the best thing, the most convenient thing is to use a frame to make calculations in a frame where that medium is stationary. That's a different thing. It's not.
Okay. You can make a calculation all day about putting yourself in a different frame of reference, no matter what. Yeah. But like in reality, there's only one frame that matters, which is the lab frame. Correct?
It matters because that's the one where you're making measurements.
Correct.
That's the meaning of it matters. Yes.
Right. So when we're talking about Airy, the only thing that really matters is the frame that he was in that that got the measurement, right? And the measurement was that angle. And
yes,
that's why it was coined Airy's failure, right? Because it didn't get the correct angle that was predicted. And you have two options: either throw out Earth's velocity, right? You say that Earth's stationary, or that the sun's frame basically is somehow the same as the Earth's frame, and then there would be no aberration. But that's okay because the light basically sped up in the water and then popped back out.
no, sorry. The prediction in Airy's time was wrong, right? Because it was 1872, and we didn't know what we know now. So my point was from the start, I don't care what the predictions were at the time, because I don't care about the history of. I might care about the history of physics. It's very important. It's some things like studying Airy's experiment and other experiments before and after that are important if you're interested in the history of science. But if you're interested in science itself and physics itself, then what you need to do is, in this case, is given what we know now and what our paradigm is now, is the Airy result expected? And the answer is yes. It's exactly what is expected because and this is again what I said from day one. The only effect of adding water is that in the frame where water is stationary, you get Snell's law. And this again, once again, I'm sorry to repeat this, but I was told that this was not what was measured, and I was wrong because Airy measured the same angle in water and air, which is not true. And so I'm not moved 1 inch from my stand on the first day that I was asked this question. The only effect is Snell's law in the telescope's frame. You have a change in the angle, and the angle changes according to refraction. That's it.
I tell you what, Beasticles, it's my preferred frame of reference. Definitely the Earth, because it is in line with our observations.
Sorry?
I'm saying basically it's in line with our empiricism. The Earth being the stationary frame of reference.
Yeah.
Stationary Earth being the frame of reference because we see the stars moving. We see the sun moving. The Earth feels stationary, so it's in line with our empirical observations, and it's more intuitive and more accurate as far as I'm concerned.
Feeling is nothing. It's not something that is used in physics, but
I mean it is vestibulocular sensation.
It's something that you have measurements. You have quantitative measurements in physics, right? And one thing, and the other thing is, of course, if you use one frame of reference, saying that you use the for your calculations and for your measurement, you use the Earth's frame of reference. Of course, in the Earth's frame of reference, the Earth is stationary by definition of frame of reference. If you make calculations on in your car's frame of reference, or in a train when the train is moving, because that's more convenient, then in that frame the train is stationary, and or the car or whatever. That's the definition of frame of reference.
No, I understand.
If you want to know what happens, sorry, if you want to know what happens, if you suppose you're on a again, it's again, I'm sorry to bring about high school level problems, but if you're on a cruising ship that's moving, I don't know, 20 meters per second eastbound, right, at a constant velocity, and then then you're bouncing a ping pong ball or a basketball on the floor. Then you want to compute what the motion of that is, or the angle, the reflection angle, whatever. What happens when you throw the ball to the ground and see and compute? I don't know what angle it would be rebounced, or just compute the motion. Would it be more convenient to do it from the frame of reference where the floor is stationary, and then compute what happens, or would it be more convenient to do it from the Earth's frame of reference, meaning someone standing on the bank, seeing the ship move and the ball bouncing and hitting a different spot on the floor every time? What is more convenient? The most convenient way of performing the calculation is just to do the calculation in the ship's frame, and then if someone insists insists in knowing what would an observer on the bank see as far as the ball's motion, then you have to convert to that frame, and which involves a little bit of calculations, and same if you have something like, now you're on the same ship, and you drop a ball inside a bottle full of oil, like something like this, which has some friction, very very hard friction, so the ball will move and be slowed down by the oil. What is the motion of the ball inside the bottle seen from someone in the bank on the bank that sees the bottle with the ball in it, that's slowing down in the bottle and falling with a slower speed than normal, and things like this. Of course, the best thing, you can do the calculation, you can make the calculation, you know how to describe the friction coefficients, and for instance, you can assume that it's proportional to the velocity. You have a so-called viscous friction and so on, and you solve the equations, but and determine the motion of the ball. But the best and the easiest way to do that is to do that in the frame of reference where the ship is stationary. And then, if you want to convert this to determine what is seen by a person on the bank, then you can do it afterwards. Of course, you can do it from the start, but it will be much more cumbersome. It will be much more complicated.
Yeah, okay, I agree with you completely. But the issue is, it's a false analogy. Because in your conditional here, we know that we're on a ship, or what have you, right? We know we're on this moving train, we know we're on this moving ship, and so that's the reality. It's grounded in reality within, that conditional statement. But with the Earth, we know, like, the argument is that we don't know that we're on a stationary Earth. In fact, we're saying that it's possible, and you guys actually say that it is the reality that the Earth is actually spinning, which is not in line with our observation. Okay, so it's not the same, because within that conditional that you suppose for the other ones, we know for a fact that thing is moving. But with Earth, it's not known for a fact. That's the whole debate about it, is whether or not Earth is moving, right? And what's supported by our empiricism is that Earth is stationary, and that the lights in the sky are what's moving. So It's a bit of a false analogy.
But real quick, just to make a caveat to that as well, Franco, that's the point of aberration as a whole, because that is the mutually exclusive evidence for heliocentrism. That is what's claimed to be mutually exclusive to heliocentrism. So, taking that fact, right, that Bradley supposedly measured stellar aberration in air, then it would be like, you would have to assume that in water you would get a different angle because of Snell's law, like you're saying, because of the experiments prior. So the idea that you don't get a different angle, and then that's exactly what to expect, that is, it just doesn't logically follow to me. It just doesn't follow.
No, he said you do get a different angle with Snell's law. But it's not different from if you were looking at it from
If you're in the
moving
sun's
frame.
frame, but that's the point. You can't. In reality, you can calculate it all day long. You can do a Lorentz transformation all day long. You can try and transform your way out of it, but there's only one actual measurement.
Yeah, so the other thing is just reified by calculations, by the model, what have you.
Correct. You might be lagging, by the way, Franco. Can anyone hear him?
And current physics predicts exactly what is bound.
Can hear you now, Franco. We missed what you said before.
According does mean
Big lag, Franco. Go ahead and start again, though. We can hear you.
So does physics right now predict that there would be a tilt? Or do they treat the water
Can
as
you hear me?
stationary?
Yep.
Now we can hear you.
The one that's grounded in reality is treating it like it's stationary. The one that they have to suppose and they model it and stuff, and then they calculate it in with their values that they believe the sun and the stars are, distances, sizes, whatever, is, you know, with Earth not being stationary.
And then they have custom expressions to balance out and match what is seen.
Can you hear me now?
Calculated in a stationary telescope.
Yeah, we can hear you. Yeah, Locksmith, they just say that like they cancel out because of kinematically, so they whatever they calculate, supposing that Earth's not stationary, it just matches what you would expect if the Earth's stationary.
So, can you hear me?
Yes.
Yep.
So the recap is, again, it's I don't care what was predicted at the time. The reason why people used the sun's frame is that at the time, or people like Bowden, I think he is in the video that is on YouTube that wants to explain what was expected in Airy's case, namely that you would have to measure a greater angle. That the reason why I introduced the sun's frame in my calculations in the first place was to show that that argument was wrong. But the point is, in the current view, it's not needed. Going to that frame is not needed in order to answer the question of what would happen if, given the situation, you add water to the telescope, because that the only effect of adding water to the telescope is to introduce refraction, meaning Snell's law, in the telescope, in the telescope's frame, and that was what was measured. Then the way you interpret the whole situation, meaning aberration as a whole, is a different matter. The question here, in Airy's case, is given the current paradigm, meaning the Earth revolves around the sun at this speed and this velocity that changes in the course of the year, is Airy's measurement expected or not? And the answer is it is. So it does not contradict, because the whole point of the discussion is Airy's experiment is called failure because it's not compatible with the Earth moving around the sun. No, it is. I'm sorry, it is. If you know your physics and you make the calculation, and indeed you don't need to make any calculation because it's really trivial from the point of view of current physics. The only effect of adding water is to add refraction. That's it. And if you contradict this, it's because you're not using physics correctly, or you're using physics from 150 years ago and using it badly.
So what causes the aberration then?
Current physics, if you're using current physics, Airy's result is perfectly explained.
Oh, wait, Franco. You just said all you need is Snell's law. Okay. Then where's the aberration coming from?
the aberration is coming from, the aberration is something different from what happens when you add water. The aberration comes from the change in relative velocity between the Earth and the star.
Right. And how can you determine that that amount of aberration, if what you're saying is that it's equivalent, we see the sun move, the sun sees the Earth move. And then if you're just using Snell's law to cancel out the aberration, then where's the aberration?
Wouldn't it be just the tilt of the telescope to the star?
Yeah, but he's saying that it's expected to have no change in angle when you add water to the telescope.
Yes.
Right, that's crazy.
No, that's not crazy. That's physics.
You would have just a small change from the, you know, the refraction of the water, right?
No, the aberration is coming from the difference in the relative velocity of the telescope with respect to the star, right?
Yeah, which
then
would
if
change
you
the
have
angle.
no water, then if you have no water, the effect of this is computable by using by starting from the frame of reference where the velocity does not change, which is the sun's, right? And you make the calculation and see what happens, what is supposed to happen in the telescope when you're when you change to a moving frame of reference which has a different velocity in two different times of year. And then you ask yourself, as a different problem, as a problem number two, as a second point of the same problem, if you want, it's not the same problem, it's a different one. Then given that situation, what happens when you add water to the telescope? And then
What do you
I'm
think
saying that if you want to make the same calculation as before, meaning starting from the sun's frame, that is more complicated, because in that frame water is moving and you don't know what happens when well, you don't know. It's more complicated to know what happens when starlight, when light crosses a air water boundary and water is moving.
That's not
Because
true. That's the point of
yeah,
that's the point of
that's the point
Fazal
of
and Fresnel.
that's the point of Fresnel and so on, which is not considered, by the way, if you take the video that people are still using to discuss Airy, which is Bowden's video, which
I've
is
never seen
on
Bowden's
YouTube all
video.
the time. Okay, but anyway, the timing argument saying using a bullet that's coming down in this frame where the telescope is moving, and saying the bullet as soon as it crosses water, it's slowed down, so it takes more time to reach the bottom of the telescope, and by that time the telescope will have moved forward, and then that means that the angle will be greater.
Yes.
That argument is wrong, because it doesn't take into account the drag. If you take into account the drag, then you will see that the moving telescope would also drag the light, and so it will the point where it will hit the bottom of the telescope will be displaced, and so will be the center of the telescope. And if you compute the distance between the two, you'll find that it's the same.
That means there's no aberration, Franco. Do you understand that?
Sorry?
There'd be no aberration if that's the case.
No, there will be. There will be.
You're saying the angle remains the same.
No,
the angle remains the same between the two reference frames, but not
it will be
between
the same.
air and
it will
water.
not be the same angle between the two reference frames. But what is important is what you measure in the telescope, and what you measure in the telescope is where the bottom, where the light hits the bottom of the telescope, and the displacement of that with respect to the center of the telescope. And if you compute that in two frames, you get the same thing, and the same thing, which is determined by the incident angle in the telescope's frame, which is determined by aberration, and then Snell's law, which determines what happens once the starlight crosses the water.
Mm-hmm. You have to include stellar aberration too, and Snell's law. That's the point of adding water to the telescope, is to make the distinction between what is actually moving. That's the point.
No.
And
that might have been
appreciate it more.
That might have been the case in Airy's time, where where what is actually moving had a meaning, and it meant what is actually moving relative to ether. But in current physics, in current physics, 120 years old physics, there's no meaning in seeing in who is actually moving. It doesn't mean anything. You only have relative motion, and you measure that. And in current physics, saying that the experiment was meant to determine who is moving with respect to whom is meaningless. You check if in current physics
To you.
what was seen is expected, and the answer is yes, it is expected. It is
'cause
exactly
you
what is expected.
you
Both
have
the
no
20 arcsecond in air and the 15 arcsecond in water. They are expected. There's no contradiction
Are
with
those two different
modern physics.
angles?
Sorry,
Those two different angles?
what are the
20
two
and
different?
15?
Yes, they're two different angles.
Right. So
Yeah,
what
the
was
two different
actually
angles, and
measured?
they're related by Snell's law.
And what was actually measured?
What was measured?
The
Was
tilt of the telescope, literally.
no,
Hey, hold on.
no,
I want Franco to
no,
answer. What
no.
angle was actually measured? The 20 or the 15?
The angle that was measured was the 83 arc seconds in March and 123 arc seconds in September, which was the angular distance between the starlight in the sky, so the incident angle, and the zenith. And the famous or infamous 20 arc seconds is half the difference between the two values. This, if you check Airy's paper, you will see that it was is what was measured, and the way he measured the 80 arc second, 83 arc second in March, and 123 arc seconds in September was by measuring which wire was struck by the starlight the moment it intersected the meridian, and then converting it to arc by using the conversion that he explains how it was done in the paper. And it explains that it was done by measuring the transit time in the sky, meaning that it was measuring the actual angle in the sky. So it was measuring the incidence angle, not the angle in water. And then it checks that this conversion from wire to angle is correct by computing actually the angle, the distance to angle correction by measuring the actual distance between wires and then using the length of the telescope and dividing the length of the telescope by the index of refraction. So it
And then
actually
what was
checks,
the result given?
he checks that this way of measuring angle, which is the angle in the air, not in water, is the same that you would have gotten if you measured the angle in water and then divided it and then multiply it by the index of refraction. So correcting by refraction. So what he measured was the angle in water, correcting it by refraction, and then measuring the angle in the star. And he got the famous 20 arc second, which is really not what he measured, but the half the difference between the two measurements.
Okay. And then which frame actually corresponds with the measurement? Or let's say combination of frames, where the Earth's at rest, Sun's frame is moving, vice versa. Which one actually satisfies the measurement?
What does it mean? Everyone satisfies the measurement because if you've seen in all the frames, you get that what is measured is consistent. Of course, if you compute what is actually measured, which is not angled, but the wire that is struck, and of course the measurement was done on Earth. So the measurement is all the quantities that are measured, angles and so on, are the ones measured in the Earth's frame. That's by definition.
Right. And the ones that we measured in Earth's frame, we treat the Earth as stationary.
Yeah, because by definition of frame, the frame of reference is where something is stationary. That's the definition. That's the definition. Yeah, if you compute the ball's movement on a ship, in the frame of reference of the ship, that treats the ship as stationary.
As stationary, correct.
Yes.
Right.
If you compute what happens when you're on a merry-go-round and you use Coriolis force and centrifugal force and whatever, you treat the merry-go-round as stationary, because that's the definition of frame of reference.
Mm-hmm.
That is a definition.
So you agree that the frame that works with the measurement given or by the telescope itself, by like you said, the micrometer reading or striking the certain wire, right? The only one that really satisfies the measurement in terms of a prediction or calculation is where you treat the Earth at rest. Correct?
No. I'm saying that if Alan or Claude that he uses to make calculations had done it properly, he would see that if you also compute what is actually measured, which is the identity, the actual number of wires that separate the center of the telescope and the wire that's actually struck by starlight, and you compute it in the sun's frame, you'd get the same result as the Earth. So no, the answer is no. If you compute the same thing in a different frame, you will get the same result, because they are consistent. Point is, it's easier to compute it in the Earth frame. Of course, if you express things as angles, then you have different results in different frames, because angles are not the same in different frames. But this is a definition again of frames.
Have you seen the response to what you're talking about in terms of the wire?
No, but I've calculated it. The one that Alan did in response to my request was wrong. Because he calculated it. The calculation is wrong, because he just took the angle and multiplied it by L, which is the length of the telescope, and this is the displacement with respect to the origin of coordinates in the sun's frame of the wire. But that is the displacement of the wire. But you have to compute the displacement of the wire with respect to the center of the telescope. So you didn't take that into account. The telescope has moved as well in that frame, and you have to take the difference between that number that he calculated and the position of the center of the telescope. If you do that, you get exactly the same number as you get in the Earth's frame.
So assuming the telescope is stationary, we can more simply make correct predictions, right? About
You said
how much
convenient.
tilt would be required or not required.
Yes, it's the more convenient. It's the most convenient frame in order to make calculations, because you have a medium there, which is water, and you know how to describe the interaction of light with water. It's much better described in a medium where in a frame where it is stationary. Same as if you want to describe the motion of a ball in a fluid, right?
Right.
You have
So any
need,
other frame would require custom expressions to
yes,
match what we naturally observe, treating the Earth as inertial as we experience it.
No, sorry. Again, for instance, Alan likes to quote this Jones experiment as if it was a catch, but it's actually strengthening my point and physics point, is that if you actually do now a different measurement, or even Fizeau's experiment, you have a moving medium on Earth. So you take the lab, and in the lab you move the water. Fizeau did this. Joan did this not with water, but with plexiglass or whatever, or glass or whatever. And you see what happens to light. It crosses
So you're saying
of a
the
moving.
water in the telescope isn't moving?
Let me finish. In these kind of experiments, you see what happens when light crosses the boundary between air and a moving medium, macroscopic medium. And the
So
answer
you're
is
saying the telescope isn't moving then, right?
It is dragged. Sorry, let me finish. It is dragged. So, and that does not mean anything. It's moving with respect to the Earth, and you have that you measure the drag, and the drag is perfectly consistent with what you would measure for the light in the frame where the medium is stationary, and then change the frame and move to a frame where the medium is moving. And indeed, you get Fresnel drag, which is a first order approximation of the relativistic composition of velocity, which is exactly what you would expect to find if you first compute what happens in the stationary medium and then transform to a frame where it moves. And this is done where you don't have to assume that anything about who's stationary and who's not. You just have that the medium is moving relative to another frame, which is a lab, and you compute what happens in the frame where the medium is stationary, and then move to the frame where the medium is moving, and you get something that is actually consistent with what is measured. So there's absolutely no.
Yeah, you can bounce around frames and apply custom expressions to match what we naturally observe in the inertial Earth frame. We get that you can bounce around and make the math work, right? But we're just looking at what we naturally observe, treating the Earth as inertial as we experience it. It directly matches what we measure and what we predict for a stationary telescope.
Yeah. So what? I mean, the answer is the answer is I was asked this: is Airy's result compatible with current physics? And the answer is yes. So I don't care what you interpreted, your interpretation. The answer is the interpretation contradicting modern physics? It is not. It's exactly what is expected.
It's all relative, babe.
What you do, and talk about what you feel or don't feel, and what you don't feel the Earth's motion is something totally different. That nothing to do with this, because the answer is Airy's result is perfectly compatible with modern physics. That's it.
Yeah, Locksmith. To your question, right? Convenient, right? It's more convenient, right? Just like it's more convenient to treat a rigid aircraft of constant mass flying over a flat, non-rotating Earth. It's easier to make those calculations. Same thing.
No, that's a different thing. That is approximation.
Well, this is approximation too. You're approximating
No,
the telescope is stationary, the water is stationary, right? And they're making correct predictions.
No.
And you're just jumping between frames.
No, sorry. The only approximation made here is, in Airy's case, is using Fresnel's drag and using first order calculations when dealing with transformations. And so neglecting terms in terms of beta square, where beta is V over C, because that would be terms of the order of 10 to the minus 8. And then we don't have measurements which are that precise. But that is the only, so that's why you're using Fresnel's drag. Fresnel's drag is an approximation. The correct formula would be velocity composition in water, and that is an approximation.
I just have a quick question. You're saying like an observer standing on Earth, looking down the eyepiece, or just standing on Earth, they can directly apply relativity and predict that there's going to be no tilt when adding water?
Sorry. Let me check one thing, because I have. Okay, no, I just remember that I have an appointment, but it's in 1 hour from now. It's less than 1 hour from now, so in a while I'll have to disconnect. But so sorry, what was the question again?
So are you saying that an observer standing on Earth can just directly apply relativity and make the correct prediction that there's going to be no tilt required after adding the water, even when assuming that that Earth is in motion?
Yes. Well, actually, there's no tilt. If you look at the experiment, which was something that I didn't understand at first, because I hadn't read the paper. I I had just seen the YouTube videos with the tilted telescope. Indeed, and this was something that people have remarked, and then I did actually read the paper and read what was actually measured, and so it's true. It was not a tilted telescope.
Right, it was a straight 90.
It was a vertical telescope, and then it was pointing. It was vertical. Actually, the angle between the telescope axis and the vertical was actually continuously monitored using spirit levels. So you knew at each instant what the angle was, which was very small because it was supposed to be vertical. The angle was of the telescope with respect to the current local vertical, and then what was measured was the angle between the starlight and the axis of the telescope. From that, plus the angle of the axis of the telescope to the zenith, then you would compute the angle of the starlight to the zenith, which was the famous 80 arc seconds, not 20. And then you would what it would do was to subtract this from the tabulated declination of the star, and which he took from an almanac, and from that he derived the latitude of the telescope. And of course, since the latitude of the telescope does not change between during the course of the year and even between one day and the next, then you would have to find, in principle, within experimental errors, you would have to find the same number. And indeed, he did find it within experimental error. So meaning that and the way he took into account aberration was that the aberration was actually already accounted for in the tabulated value for the declination of the star. So, but what he actually measured was the actual measurement. If you read the paper, is the angle of the starlight with respect to local zenith.
Oh, why don't we see any effect of this moving water in the telescope? Why does it just match a stationary telescope?
Sorry, say it again.
Why don't we see any effect of this moving water in the telescope? Why does it better
Because there's
match a stationary
no
telescope?
moving water in the telescope. The water is stationary in the telescope. It's not moving.
Right.
Well, if Earth is moving, it would have to be moving there.
Because again, in current
This is where the
physics,
frame breaks, right?
in
Because
current
you're
physics,
treating the water as stationary, but you're also saying that Earth is in motion. So that water
yeah.
can't be stationary; it has to be in motion.
No, sorry.
Why
This
don't we
is not.
see any effect of that water in motion? Why does it match a stationary telescope with water?
Sorry. Sorry. This is completely misplaced question. Again, if you add water in the telescope, water is stationary on Earth. So, from the
Brother,
point of view,
if the water is stationary, then welcome to stationary Earth. The water can't be stationary in your explanation because you're claiming it's in motion.
No. It's
Yes,
just
yes.
He doesn't have a rebuttal, dude. He's stuck. He can't just
No.
appear to reference frame as a rebuttal, dude. When the reference frame of the Earth is the rotating reference frame, dude.
Okay. So let me say it again. So you are on Earth. You fill the telescope with water, and then you have light coming from any source to it. Any source. This is the contemporary point of view, because due to relativity, light coming from any source is indistinguishable. You cannot distinguish light coming from a moving source or a stationary source. It always travels at the same speed. So you have light that's coming at an angle, say 20 arc second, to your telescope. And this light comes from the star. It comes from a candle. It comes from the sun. It comes from a flashlight. It comes from whatever you want. as long as it comes at that angle, relativity tells you that it's not distinguishable. It's just light coming at that angle. And so what it does, it's always the same thing. There's no way of distinguishing light from a source from one source from one source and another if you're only dealing with angles. Of course, if you have a refraction index that depends on frequency, that is another matter, and then you will have to take into account what the frequency is. But given visible light behaves exactly the same. So you have, say, blue light. Take blue light. You have a blue light coming from a LED, or coming from a star, coming from a torch, coming from anything. As long as it hits stationary water in your lab, it just undergoes refraction with Snell's law, and this is what physics predicts. It doesn't matter what star comes from. So
You can't say stationary water. That means stationary telescope. That means stationary Earth.
no, it means that water is stationary on the Earth, because
Thank you.
this is, yeah, on the Earth. Yes.
Yes, thank you. Welcome to stationary Earth.
No, welcome to stationary water on Earth.
You keep invoking the equivalence principle, where all reference frames are valid,
Yes.
right? And there's no preferred reference frame, dude. We get it, but there are contrary to what Einstein believed and what you believe and mainstream paradigm believes. There are experiments that one can do to show a superior reference frame. Airy's failure is one of those experiments.
Sorry, but again, can you hear me?
You didn't hear that?
Yeah, we can hear
No,
you, dude. You've been gish galloping
okay.
for hours, dude.
Okay. So no. So yeah, but I don't know what you're talking about. But anyway, the point is, again, the question is, yes, I'm invoking the equivalence principle, the equivalence principle, and I'm invoking actually not the equivalence principle, because I'm not invoking general relativity. I'm just invoking. So the equivalence principle is something different. It's got to do with general relativity. This is special relativity, which says that all inertial frames are equivalent, and this was also true in Galilean Newtonian relativity. The only difference being the behavior of light between special and relativity and Galilean relativity. But yes, I'm invoking that because my purpose is to answer the question is of, does current physics, when current physics is this assumptions of special relativity, is that compatible with Airy? And the answer is yes. So that's it. I don't care if you then say that, I don't know, there are other reasons for declaring relativity wrong, which I don't know of, but it's not this. This is perfectly
Because when we
compatible
ask
with
you what frame does it work in, you say the frame where you treat the water as stationary. Oh, so that means the telescope is also stationary. Where's the telescope? Oh, it's on Earth. It's stationary as well. Welcome to stationary Earth.
No,
We
welcome
keep
to not
looping.
understanding what frame of reference is. Sorry, but you're not
I
understanding
get
what
you
frames
can
of reference
describe
are.
motion from any reference frame you'd like, right? I get that. I understand that. But the the frame in which you can directly apply relativity and classical mechanics is the inertial Earth frame.
Sorry, relativity means that you can switch between frames, right? You cannot apply relativity to one frame because that wouldn't make sense. The word relativity means that you can use frames, the frame you want, and you get the same physics, right? So again,
I said you could apply it more directly.
your
In laws
conclusion.
of physics, in classical mechanics, you can apply laws of physics directly in an inertial frame. In relativity, you can apply them more directly. Like I said, or like you said earlier, it's going to be more simpler. You don't need any transforms.
Yeah, you don't need to do that, but if you want, you can, and you find the same result.
Yeah, we get that.
Yeah.
I understand. But the base frame, the most simplest one, is where the water is stationary in the telescope.
Yes, and in Jones
Thank you.
and in Fizeau, and in Fizeau, it's the frame where the water is stationary, which is not the Earth's. So
The water is stationary. It's in the telescope,
yeah.
which is also stationary.
Now take
Right.
Fizeau's experiment.
Wait, you said the Earth wasn't stationary there. The water in the telescope is stationary. The telescope is on the Earth, which is treated as stationary.
Yeah. Yes, because this is a definition of frame of reference. Now you take Fizeau's experiments where you have moving water, and you find that the calculations are easier in the frame where water is stationary, which is not the Earth. So in a different problem, you have a different frame where it's easier to make a calculation.
What water is stationary? The water in the telescope?
I'm talking about Fizeau's experiment. Look it up.
Okay.
There's a different experiment where you have water that's moving with respect to Earth. And in that experiment, you find that the calculations are more easily done if you start from a frame where the water is stationary, which is not the Earth's. So it depends on the problem. It depends on the problem. Again, if you have a bottle of milk, a jar of milk, where you have to determine the motion of a seed in this milk, and the milk and the jar of milk is in a train that's moving. The best frame in order to calculate this is the train's frame, which is not the Earth's. So it depends on the problem. Which does not mean that you cannot do the same calculations in other frames.
And the telescope is on Earth, so either
you have lots.
The water in the telescope is either going to be moving or it's not.
What?
The water in the telescope is either going to be moving or it's not. You disagree with that?
Yes.
Okay.
Motion is only defined relative to something else. So
to the observer on the Earth, on a stationary Earth.
Yes. Okay. To an observer on a train, the train is not moving. To an observer in a car, the car is not moving. Okay. To an observer in ISS is not moving. You have only motion that's only relative to something else. So in a frame of reference, by definition, things that are in that frame of reference are not moving relative to yourself. If that frame of reference can be moving relative to some other frame, and that's the whole point of relativity, either Galilean or Einsteinian, is to declare that the physics is the same in a whole class of frames that are moving relative to one another.
Right. But we're treating the Earth as inertial, right? And we experience it as inertial.
We're treating it as inertial.
Stationary in regards to acceleration.
Because in this problem, you don't have that acceleration actually significant. The fact that we are treating the Earth as inertial in general, actually the Earth's center of mass as inertial, that is due to the equivalence principle, which is something that has got to do with general relativity, or even with the Newtonian relativity, because even in Newtonian relativity, you have something in free fall can be considered an inertial frame of reference, but then of course only a point, because then you have that the Earth is spinning, and the spinning Earth cannot be considered inertial, and the effect of non-inertialities on that is something that is measurable and something different. But that is something that's completely different from the point that we're discussing here, which is Airy.
So the water in Airy's telescope is moving. There should be no effects from this, is what you're saying. Is that wrong? Or just those minimal effects that were observed, but not a significant tilt would be required if the water is moving?
No, I'm saying that no, the effects that are minimal are the effects due to acceleration. The effects due to the 30 kilometers per second are none because of relativity.
Okay, so similar to like MMX explanation, right?
Yeah, exactly. Yeah, MMX is totally, again, trivial and from the relativistic point of view, because when you rotate if you are on Earth, then you can consider it an inertial frame. So light propagates at the same speed and velocity at the same speed actually in all directions. So if you just rotate by 90 degrees your interferometer, you would have no effect, because you have the same speed of light, which was not the prediction, because the prediction thought that there was different speed of light in two different directions due to the Earth's motion, and that the Earth's motion through ether. But once you remove the ether, you have you don't have that problem. So it's completely trivial. You don't have, in spite of what some of you yell that you have to use contraction or whatever, it's just from the relativistic point of view, MMX is just explained by the fact that speed of light is the same in the two arms of the interferometer.
But it's kind of different than MMX because it has that water, that medium that you have to account for. Because you see in Fresnel and Frizzot, the moving water has observable effects. But you said the water in Airy's telescope, which is moving, we're not predicting any effects from that moving water. So that's where it's kind of confusing.
It's kind of confusing because again, the Fizeau experiment was measured in a frame where water was moving. Airy is measured in a frame where water is stationary.
Well, then welcome to stationary Earth. That's where, because you say, because he's moving. In Frizzot, he's moving the water, but in Airy, the water is moving in the telescope.
Yeah, you do two different experiments. They're two different experiments measuring two different things. And
moving water.
They're perfectly consistent. They're perfectly consistent because, again, if you move to a frame, if you wanted to move to a frame where water is moving, where Airy's telescope is moving, which you don't observe because we're not in a frame where water is moving, we're in a frame. Airy was in a frame of water stationary, but if you wanted to calculate what an observer, which is stationary with respect to the sun, would have seen, then it would have seen an effect which is Fresnel's drag, which is the same as Fizeau measured and Jones measured. He would observe the same, and that would lead to the same result in terms of which wire was struck by the light. You can make the calculation and compute it. I asked Alan to do it. He did it wrong. Now I hope he will do it again right. You have the same results seen in the two frames.
You're saying the transformation reconciles the math?
I'm saying that the transformation is perfectly consistent, and that the current description is perfectly consistent, describing the same phenomenon in two frames in a perfectly consistent way. There's no contradiction.
Yeah, Franco, it describes it maybe perfectly, but when you look at Newton's bucket, where the water is rotating with the frame, and you take that with a telescope, then that when that water is rotating with the frame, it's moving with the frame as well. But there is still movement in that water going outwards from its center. So to say that that telescope is on the move while you're measuring that light, I think that's a bridge too far.
Oh, sorry. Newton's bucket has something totally different, and something that has got to do with rotating frames, has got to do with accelerated frames, has something to do with general relativity. So it's something that's totally not applicable to the current problem.
Yeah, but we're talking about a moving Earth, where Earth itself is on the move and not the stars. So it definitely makes something say something about the ground you're standing on.
Yeah, but relativity has a dodge. They don't. They say the orbit is not, rotational motion. It's curvilinear.
Yes.
Yeah.
And it's a free fall. It's a free fall. So it's the center of mass of the Earth is a in the first approximation. It's a inertial frame, and then you have the fact that it's actually not a point-like object. That you have that the Earth is actually has got a size, a non-zero size, that has got an effect, and the effect is the tides, the tidal forces of the sun. So the sun's contribution to the tide forces is actually due to this rotational motion, revolutionary. I don't know how to call it. The orbital motion of the Earth about the sun, and the fact that it only cancels out exactly in the center of mass, or approximately in the center of mass of the Earth, but on the surface there's a difference between, from a Newtonian point of view, there's a difference between the centrifugal force and the actual centripetal force, and then because they have two different dependencies on the distance, and so you get the tidal forces. So that is something that is measurable, actually, tidal forces.
Yeah, but that's a force going two ways.
What do you mean?
You get tides coming in and tides pulling back out. That's a two-way motion.
Yes.
That's a harmonic motion.
Yes. So
when you got the ball spinning in one direction, it doesn't make sense.
Oh, no, it actually can be calculated very, very with very good approximation. You just make the calculation properly, and you see that you have the quadruple expansion of the force, and you see that it's got exactly the shape that you actually measure.
Yeah, but when you're looking at how fast we're falling into the sun with 30 kilometers a second, when you calculate that back to an hour, that's 108,000 kilometers in an hour. But in 24 hours, we make a full revolution of 2,592,000 kilometers. So when you look at that distance we're traveling in a day, and you look at the distance of the moon, and you look at the size of both of those objects, and to say that one of them is 93 million miles away is a little bit awkward.
It's awkward if you cannot make the calculations, because if you make the calculations and you use geometry and you use it properly, you see that there's no contradiction at all.
Yeah, but we got the celestials moving in a vertical field over us, not in the horizontal field.
Sorry?
If you look at the stars and the moon, and you look at Broglie's theory, that places all the celestials moving vertical over us, not in a horizontal way.
I don't get it. I don't. Sorry, I don't get what you're saying. But no, I can assure you that all the apparent motion of the objects in the sky are perfectly compatible with celestial mechanics. This has been studied for centuries, you know, and
Yeah, but
measured.
even if you look at the gyro, how it creates that lift by its vertical and its horizontal part of the field, and you look what the Earth is doing, and we only have the waters moving in the horizontal plane, but we got the gases moving in the vertical plane. So you got two motions on the Earth itself.
Oh, I'm sorry, I'll have to see it written down, but I can assure you there's no contradiction. The people would have realized earlier than this.
Franco, what do you think about GPS clocks refuting relativity strong equivalency principle?
I don't know
Strong
about this.
equivalence principle. Well, relativity strong equivalency principle says that a uniform uniform acceleration effects are going to be physically indistinguishable from uniform gravitational field effects. But GPS clocks show that both cases are distinctly accounted for and apply distinctly different correction formulas
I
that
don't know.
account for different factors, and their effects accumulate at distinctly different rates.
I don't know for many reasons. One of which being that I'm not expert in general relativity, so I don't know. I don't really know these things at a depth that allows me to discuss them in detail, and so I have to look them up. And so I don't want to discuss things that I'm not an expert in. And one thing.
Mhm.
Second, just a comment. It really strikes me as really, say, peculiar that you people are using GPS as a rebuttal of physics because I don't know if you've heard, but GPS is measured on satellites. So even people like Alan using, I don't know, his famous Sagnac effect and whatever, but then he's assuming that these satellites that are measuring GPS are orbiting the Earth, when in your view there should be no gravity, there should be no satellite ever.
That's not my view. I think that GPS satellites can be more simply explained with classical mechanics of relativity.
Yeah, classical mechanics of what? Of what?
And they actually refute
Of,
relativity, the strong equivalency
yeah,
principle.
a classical mechanics. How does a classical mechanics explain a satellite over a flat Earth with a dome?
Well, yeah, so you're just straw manning the
No,
position,
I'm not
right?
strawmanning. I'm not strawmanning. I'm saying that you
When
are
did I
using
ever
things
bring up
that
flat Earth
contradict.
or a dome or like any of that?
That contradict.
I'm just talking about.
Saying.
Yeah, I'm just literally talking. You can keep your globe for now. I'm just refuting relativity strong equivalence principle.
Yeah. So what I'm saying is that you don't have a coherent picture. But okay.
Well, I mean, I'm not even going for like. I'm not even demanding you adopt a globe right now. You can just hold on to your bar right now.
Okay, whatever. So, but in any case, I'm not expert about GPS and about general relativity. So I can only answer things I'm a little bit expert on. So and special relativity, I'm fairly expert on because we use it every day in particle physics, and so and I've also taught that for 20 plus years. So in electromagnetism courses. So in special relativity, I feel that I'm quite confident. And general relativity, I prefer not to discuss it.
All right.
But sorry, I really have to disconnect now because I have this appointment. I risk being late. Sorry.
Thank you for your time, Franco.
Thank you for keeping this civil, contrary to what happens on next spaces. So sorry.
Nope. Oh, you can bring a horse to water. Can't make him drink.
Well, yeah, pretty much, yeah. What's the current argument?
General relativity, Airy's failure, Earth's motion.
Yeah. Guess I don't really know too much on the general relativity stuff.
Do you think
Airy's-
aliens will visit? Do you think aliens will visit the Vatican first or the White House?
I don't know.
They're gonna rob the Vatican.
I don't know. Airy's failure is, I feel like that's kind of a good, I don't know what you would call it. It's not really an experiment, but I don't know. Like, if this dude did it, what, like 50 years ago, hasn't someone done it recently with like modern technology? And
We did it in the 1800s.
exactly. Like, why has someone done it in the 2000s? Like,
I mean, MMX is like a refined kind of version of it. It was supposed to be definitive, detect Earth's orbital velocity, right? So,
what was that? MMX.
oh yeah, Michelson-Morley experiment.
But
yeah, classical mechanics doesn't have an answer for it. They had to come up with relativity to kind of answer this question as to why we can't detect Earth's orbital velocity. So they came in with relativity. Instead of us going on a curved path around the sun, we're now going, free falling straight in a linear path, or they call it a curvilinear path, right, around the sun. And that's why we can't detect Earth's orbital velocity. So, yeah.
yeah, true. I couldn't detect it, so I just made up a bunch of stuff to kind of, I don't know, just to kind of dismiss it.
And then for all practical purposes, we still use classical mechanics. Works pretty good for all terrestrial purposes.
But I don't know, like, does that even really matter? Like, if you're building a bridge or a building, like, they're not using any of that, are they?
No, only when they need to explain why they can't detect Earth's orbital velocity. For all of their purposes, you can just use classical mechanics.
Yeah, but with that experiment, you're placing your apparatus on the Earth, and that's 6 to 8 kilometers a second they measured. If you take that back to that 30 kilometers a second and you divide that by 4, you come about at 6 to 8 in between. That's 1/4 of the total world. So if you look at it, we're having 4 corners and you're just measuring that thing on one corner. Wouldn't it be logical that you're just measuring the speed of one part of the world?
Yeah, I don't know. What is that all? Just space physics or something? Like, I just feel like that's all like just irrelevant bullshit.
Because all we measure is oscillations coming from the Earth itself.
Yeah, when you refute relativity, you get rid of the only explanation for why we can't detect Earth's orbital velocity. All right, and if Earth
Because
is
we have
stationary,
none.
it's in the center of creation.
Like detect on Earth?
What was that?
So could one use external references to measure the Earth's orbital speed?
Yeah, any terrestrial or optical experiment.
Yeah, but we could use like the International Celestial Reference Frame, though, couldn't we?
Use the International Celestial Reference Frame.
Yeah.
What is that? The ISS?
No, VLBI is one of the major parts of it.
B says International Celestial.
Yes, International Celestial Reference Frames.
Tell us about
You
it.
got you got the terrestrial reference, international terrestrial and celestial reference frames.
All right, tell us about it.
Like VLBI.
I mean, what about it? You brought it up.
Yeah, well, it uses external sources for basically measuring Earth's reference rotation and movements.
What, with like parallax?
No, it's by measuring radio signals, the delay and amplitude between different radio telescopes. You got them spread out all over there, more or less all over the surface of the Earth.
Mm-hmm. And what about them?
They give us a very accurate measurements of the Earth and how it moves. I
They're
think they
on
use about what
Earth
is about.
and they're detecting Earth's orbital velocity, is what you're saying?
Yeah, as well. Yes.
So Einstein
I
was
think
wrong. Relativity is wrong.
no,
What
no.
Franco
We're
was just
using.
arguing about was
Hang
wrong.
on. We're using external reference points.
Yeah. External reference points. But you said they were on Earth making these measurements.
The telescopes are, yes,
Uh-huh.
but the sources used, quasars, are not.
They're pointing at distant stars for reference.
Quasars, really far off objects. I think there's about almost 2,500 of these sources today that they use.
Mm-hmm. But these telescopes, the Earth would be stationary relative to these telescopes.
Well, at a specific point, yes. But the thing is that if, like, when you have radio telescopes facing the same celestial object, there is a time delay for the radio signals to reach each of the different telescopes. So you know that the radio waves have to travel at different distances to reach the different telescopes.
I don't know. So these telescopes are detecting Earth's orbital velocity or no?
By these measurements, it can be calculated.